अरे वाह, सबसे बेस्ट मिठाई हमें फेवरेट। अरे बैठिए खाइए, खा के दुनिया मेहनत करने वाले हो तुम दुगना चौगुना तो कर मैं अरे यार नहीं आए नहीं स्टार्ट माइक ऑन माइक
Hello, everyone. Good evening. Okay, I think we can start. Okay, so today we have like a few things to cover. So first thing is like we want to cover 2D arrays. Uh, then we have like questions left from arrays that we wanted to discuss. Okay. Now first of all, like we yesterday saw a sub array. 2 pointers that's not there right now, so that is there in like module 2. So for now, I guess we don't need that concept. So 2 pointers will cover in module 2. So if there is, I don't think so. There is any question in the there is no any question in the assignment as well related to that, right? So there are question of subarrays which we have covered yesterday. Okay. I'll cross check because as far as I recall, it's not there in this module. It's there in the next module. Okay. And since 2 pointer is also not there, searching is also not there in this module. So that is also not here. I'll just cross check, right? I'll just cross check and Array subtraction, yes. So we have two questions to discuss: array addition, array subtraction, diamond pattern. Three questions actually, and a spiral matrix. I discussed. Did I not discuss that question? अच्छा spiral matrix पे discuss नहीं हुआ है. Okay. ठीक है, so spiral matrix is a easy one comparatively. This is time complexity consequent multiple where the correct answer is log n. This is infinite. This is an infinite loop. So this is a error. Yes, I remember there was one MCQ with this mistake. So actually this is a mistake in the options. So so in the question actually it should be starting with 1, Nitish. Okay. So otherwise it's an infinite loop, right? So you're correct there. So it's an infinite loop. The time complexity should not be log n. Spiral matrix is 2D. Yes, spiral matrix. Spiral matrix is a 2D question, right? So we have not discussed that yet. Okay. ठीक है, spiral
अरे मुझे भी 7.2 बताया था, मैंने बोल दिया था ना सर 8 से नीचे काम नहीं करेंगे. अभी तो आया है ऑफर लेटर.
Sorry. Okay, so let's start, right? Let's start discussing, then only we can proceed. Pascal's triangle. We know array, so we can now print Pascal's triangle. That's there. Sorry. I'll take 2D arrays question, not now. 2D arrays questions we have started. No, we have not even started. Just one quick thing. Let me just see. So we'll cover few things today. So let me clear out the agenda that what we are going to cover. So today we are going to cover this addition subtraction problem. So this we are going to cover anyways. Okay. Array addition and subtraction. Okay. And we are going to cover 2D arrays. So this is what I'm going to cover today. If there is any questions to discuss, we'll take that. If we are left with time, if we are not, then we'll try to stick to this. Okay. So let me quickly cover up the easy one so that at least we are having some new theoretical concept so that you can practice more questions. You have 2 more assignments that's there. So let's start with 2D arrays and then I'll cover up this. So I don't need more than an hour for 2D array because we already know arrays, you already know memory. So this is going to be easy. Okay. So what is 2D array? So see, till now, whatever we learned about memory is that we can have one block of memory that we call as a single variable, right? So 2D array concept wise, it's very small concept, right? There can be a lot of questions, but questions are comparatively easier. So I don't think you'll face difficulties. We'll need to solve a few questions. There are few variations questions that I'll show you, but concept wise, there is very few concepts in it. Okay. So let me explain you in terms of memory how this 2D array is, what it means actually. Sasha, did I miss any question? Array subtraction, I'll solve it, right? Don't worry, right? If there is array subtraction, I'll solve it. Is this one? Is there any questions related to the time complexity assignments? That's doubt. So there are 1-2 questions that were mistake. Last time I've informed it should have been corrected, but if they are not corrected, so it is 0 to n. This is 0 to n. I plus plus I into 2. So inner loop is an infinite loop, right? Inner loop is an infinite loop. So this time complexity is infinite, right? So that's an infinite time complexity because the inner loop is an infinite loop, right? Just took the inner loop, but j into 2 is never going to be changing from 0. And if n value is starting from 1, then it is an infinite loop always, right?
Sir, this is not inner loop is log n.
Inner loop will be log n if j starts from 1, right? So if j starts from 1, then the value is changing, right? So if the j is not starting with 1, just look at that. The value will not change. J will always be 0, right?
Okay, sir. Got it.
Understood how it is infinite. So see, when a for loop starts from 1, this one variation I guess I covered in the class and from that. So for example, if I write this I into is equal to 2. So addition is different, right? Addition, it doesn't matter from wherever you're starting. Every iteration when you're doing like I plus plus or something, it is increasing, right? But when you're not increasing it, when you're multiplying it. So when it starts with 1, you start with 1, then you multiply it with 2, so it becomes 2, then 4, then 8, and so on. It is increasing. But if you're starting with 0 and you keep on multiplying, what happens actually is you still are stuck with 0, right? Your value is not increasing. Now, like let's say n is any positive number greater than or equals to 1. This is always going to be true and you're stuck in an infinite loop. Okay. Okay. So let's talk about 2D arrays first. Okay, I'll cover these two questions, but let's cover 2D arrays first. Okay. So we already know array, and we know that there are only two ways to claim memory, right? There are only two ways that using which we can ask memory. Either we take memory from the stack, which we can use as just direct single variables. We can create a single variable in the stack, like named A, B, which for which we already know how much amount of space we are going to need. So for example, it is an integer variable. So let's say we need 4 bytes. It is a long variable. So let's say we need 8 bytes. We already know the space. So these things are created in stack. Then we came to know there is something like heap, which creates things like array, for which we don't know the memory size, right? We may be knowing accurately, we might not be knowing. We can only know until the user gives input, then only we will be able to know. So on those situations, we don't know the size. So we give that space into the, we put those things into the stack. Okay. So, array is one such example which goes into the stack because we might or might not know the size of this. And we call this kind of memory as static allocated, right? And this is known as dynamically allocated, right? We understood these concepts. Take a stack, heap, stack and heap, all a concept we understood, right? So we call this as stack memory and we call this as heap memory. Okay. Now, what is 2D array? So you can imagine 2D array is nothing but a bunch of 1D arrays. Okay. So actually in memory also, this is a bunch of 1D arrays. This is not actually a 2-dimensional array. This is a multiple 1D arrays. And they can even be present at different places, not just they are always like, it can be that it is a possibility that the 2D array looks something like this. Again, in memory, all the 1D arrays are actually adjacent to one another, but it is not always the case, or the 1D arrays might be in this fashion. Sorry. So there can be one 1D array over here, another 1D array over here somewhere. There might be few variables in between, right, given to some other, the spaces might be given to some other variables. So we got 1D array over here, one 1D array over here, one over here, some 1D array over here. Okay. So these are nothing but multiple 1D arrays. And what do we know about 1D arrays? How do we remember any 1D array? So if we remember only the base address of that 1D array, right? We only know that the base, what is the base address? What is the address of the A of 0? What is the address of the starting of that 1D array? What is the logical address of the start point of this 1D array? We just know that. Now, whenever we want to access any particular element, we just say A of 5. So what does this mean? The base address plus 5 times whatever is the size of this. So 5 into, let's say it is integer. So it will add 20 bytes to the base address. Whatever address we'll get, we'll just try to tell, okay, this is A of 5. Okay. So same way 2D arrays works, it's just multiple 1D arrays put together. Now just think it like 1D arrays and just think like you are dealing with multiple 1D arrays. You're like maximum of the confusions will get solved by thinking it in this particular way. Achha. So if you have doubts on let's say the MCQs, we'll discuss them. Okay, so I'll discuss them. I don't think it will take more than 15 minutes. So you can quickly go through them. Okay. I see a few doubts in the chat. So okay, we'll discuss them. Okay. So we used to create a 1D array like this. And when I used to print something like A or dot println A, we used to see the base address, right? So now if I run this, we used to see a base address, right? Now let's try to do the same thing. Let's try to create a 2D array and 10, 10 size. See. So when I print A, it simply tells me the base address of the first of this. Now, when I print A of 0, let me just try to run print A of 0. See, we are seeing the same base address. Okay, let's look at this. Let me just copy this one. Okay, see. So what is the base address that you're seeing over here? This is the exact same base address that you're seeing when you're printing A of 0. What does this mean? So when you're printing this 2D array space address, it means that whatever logical address, we understood about physical and logical address. The address that we see is logical address. The address that is actually the address of the memory, that is the physical address. We don't have to deal with physical address. That is like we deal with the logical address. Yes, there is one extra, this square bracket that like array is adding. So it is telling that this is like the first A of 0. When you print A of 0, it prints it accurately that this is the actual logical address, right? That's how it differentiates, right? Okay, so that is what array is adding, but the actual address is same. Now, if I print A of 1, okay, and I try to run this, okay. See, this address is different, right? I guess 2C. Is there anything different? No, it's printing the same address. I don't know why it's printing the same address. Could have been different. Okay, let's try to run this again and try to print both of them. Just a second. Why they are pointing to the same address? Let's try to run this. Oh, see, now it is printing the different address. I don't know why it printed the same ones. Okay, so this is the actual base address of A of 0. This is the actual base address of A of 1. Right now, if you print the A of 2, A of 3, you'll see the same base addresses that you were seeing in case of like 1D arrays. All these are nothing but 1D arrays. You are having different base addresses, right, for each of these values. See, so every array, every 2D array is nothing but multiple 1D arrays put together. Okay, so if you think it in this way, all your problems are simpler now. So you already know 1D array. You just are given, just think it like you're given multiple 1D arrays. You're given 5 or 10 or 15 or 100 1D arrays, and you have to do some operation on these many 1D arrays. Okay, if you want to represent them, so generally the 2D array is represented by something like this. Okay, let me just do anything. So this is the actual base address, right? I don't know why it is printing the same thing when I am like just removing other. So that is the value, right? If you print this A of 0, 1, I'll come to that part. I'll just come to that part. Just let me just clear this one out. Okay. So actually, these are these are multiple 1D arrays. They can be present at different locations in the memory, right? Now, how do we represent this? So actually, we don't represent it as multiple 1D arrays. You'll always see the 2D arrays are represented something like this, which is having rows and columns. Okay. Now, whichever way suits you the easier to understand, you can pick that one. Okay. So you can treat it like a matrix. Okay. So you can treat this you can treat this 2-dimensional array as a matrix. Now, what is a matrix? Matrix is basically a grid kind of thing, which is having rows and columns. We have 0, 1, 2, 3, and we have this 0, 1, 2, 3, 4. Okay. Okay, I got it. Why did we see that time A of 1 was getting the same address? So what happened was in the next run, when I was printing A of 1, so it was giving like the same address to A of 1, right? So, okay, let me just talk a while. So when I printed just this, I initially got this for A of 0. Next time when I ran this, this was not present and this line was not present, I ran for A of 1. That A of 1 was getting this. So that was, I guess, a very like good coincidence that A of 1 also got allotted the same space that earlier A of 0 got. So whatever the first array got in the first instance, second time when I ran this code, the same address was given to A of 1 coincidentally. So that's why we saw the same logical address. Okay. Ideally, you'll see different logical address for each of the arrays, because each array is a different array in the memory. That was like some coincidence that happened. The compiler returned the same kind of logical address. Okay. Okay. So now, like you can think it in this way that each, so what is this? So this we call as rows. Okay, this we call as rows, and these are nothing but multiple 1-dimensional arrays. Okay, so these are 1-dimensional array. This is the first 1-dimensional array which is A of 0. This is the second 1-dimensional array which is A of 1. This is the third 1-dimensional array which is A of 2. Okay, this is the fourth 1-dimensional array which is A of 3, and so on. Okay, and each of these arrays we have like earlier, similar to earlier how we had the values. So in A of 0, we have the value 0, 1, 2, 3, right? Same way. Now, how do you access any value in the array? So for example, A of, so what is your array now? So your array is not A, your actual array is A of 0, right? Now, how do you access a value in the array? You just pass the index, right? So if you want to access 0, so you just write A of 0 of 0. So this is actually representing the one-dimensional array, and this is representing the index in that one-dimensional array which you want to access. Now, whenever you do this, what you see the value, right? Whenever you write A of 0, A of 1, for a one-dimensional array, you see the value. Same thing goes over here. When you write something like this, you see the value. When you're writing this, you see the logical address, right? Now, what does A print? A prints the logical address for the very first array, which is A of 0, right? It almost matches it. So let me run it again. Okay, there is some difference that is happening. Okay, I don't know. It might be storing something else as well. Okay, so it is storing something else that was not found. So you can remember it from here. So this is this again points to a logical address. I guess so. Then it might be this scenario. There's whatever this A points to, whatever logical address A points to, that stores all the logical address of A of 0, A of 1, A of 2. So whenever you write A of 0, it tells you which array you want to access. Okay, I'll tell you this how this is working actually. Okay, think it like this. So what is A? A is actually storing an array of logical address. So this simply stores an array of logical address. When you write A of 0, it tells you that this is the logical address, which is this. This is the value actually it is storing. This is the address. Okay, let's call it address 1. A of 1 is storing an address 2. A of 2 is storing address 3. A of 3 is storing address 4. A of 4 is storing address 5. Okay, something like this. Now, whenever you print A, it gives you the address. It gives you the address of this particular array. Okay, which is just storing the addresses of other arrays. Okay, so this array is not actual array that you are creating. This is the array which is storing the address of other arrays, other one-dimensional array. Now, when you print A of 0, it gives you the address of logical address of the first one-dimensional array that exists in memory. Okay. So this is the first one-dimensional array that exists in memory. And when you print A of 0, it gives you this array. When you print A of 1, it gives you the logical address of this. And when you try to print like any values, so this is A of 0. Okay, this is A of 0. This is A of 1, the logical address of this second array. Okay. Okay. And this is what it is storing. And when you print A, you're seeing some different logical address, which is like the address of the array which stores all the logical addresses. Okay. It should be vertical or horizontal. So generally in memory it's horizontal, but it completely depends on how like the operating system is managing the memory, right? Say the operating system feels like, so generally the memory allocation happens in horizontal format, right? Operating system uses them, but this is again like completely dependent on operating system, how it manages its memory, right? So there is no way we can know whether this array actually exists in a horizontal form in memory or it exists in a vertical form. Right, but that is like because the operating system deals with it, so there can be variations. If you see in Windows or Mac or in Linux, how they manage it might differ from different places. It is something which neither our compiler handles. Okay.
Hello, sir.
Yes.
So why the address of A or A of 0 difference, sir?
So A is the array which is storing the addresses. Okay, so think it like this. Dekho. So we created earlier when we created A. Okay, let's say we have A as one-dimensional array. So let's call it some other name. Say so avoid confusion. Let's call it as a B array. So let's say B is a one-dimensional array, and how it used to get created. So when I create a one-dimensional array, so see why the memory is not just creating a two-dimensional array directly. So let's say you are using a lot of memory and you don't have a space like grid which is of 1000 cross 1000 site. Okay. You don't have a 10 to the power 6 grid available in memory like continuously to give it to a two-dimensional array. So will the compiler tell you that I don't have this much space together, so I can't give you this much space? No, compiler will try to figure out whether it can do something to give you the space. So compiler, what it will do is it will try to give you, it will try to think how we were doing in one-dimensional array. So it was giving one-dimensional rows. Now, what is this two-dimensional array? This is nothing but a combination of multiple one-dimensional arrays. So instead of giving all the spaces together, it will try to give it in the one-dimensional array form. So what it will do is it will give multiple one-dimensional arrays. Now, since we have multiple one-dimensional arrays in different places, right? So this is one array over here, which is A of 0. This is one array over here, which is A of 1. This is one array over here, which is A of 2, right? So we need to remember so many addresses, and we are actually doing. So A of 0 is remembering an address, A of 1 is remembering some different address, A of 2 is remembering some different address, right? So all this A of 0, 1, 2 is remembering some different address. Now, what is this? So this is something like how we access arrays, right? So when I print A, so what is A actually? So now what is A? So if A of 0 is an address, what is A actually? So A is an array. A again is an array. This is like the array which we are not seeing. This is something which Java compiler is maintaining. So what this is storing? This is storing the addresses of all the arrays. So when I create a, let's say 5 cross 5 matrix, okay? So it is having it will have five values. We cannot so this won't be present. Let me erase this one. Yeah. It will have 5 values like this. Okay. And what this would these values will have, this value will have address 1, address 2, address 3, address 4, address 5. So it is basically an array which is storing these addresses. Now this is a different array, that's why it has a different address. So this is the address of this first array, which is storing the addresses of other arrays. When you try to get A of 0, it gives you the address of first array, A of 1 gives you the address of second array, A of 2 gives you the address of third array. Understood? So that's why this is varying. This is like a different array, which is pointing to some other address, and this is some different array, which is pointing to some other address. This is one which Java is maintaining, so we don't have to ever interact with this. We don't have to ever anything do with these addresses. We just are worried about these values. But thinking in terms of multiple one-dimensional arrays makes a lot of problems easier, I have seen. So if you like, I would say you can prefer this approach in a lot of problems, because the thinking, like thinking it in this way will make it easier for you to solve problems. Yes. I have.
Sir,
yes.
can I ask something?
Yeah, sure.
Yeah, I have a doubt in this. You said the base address is the address of the first element of the array. So how can these both differ? Both are the same thing.
Sorry, I did not get the complete question.
The base address of A and the base address of A0 should be the same. Yeah?
A and A0 will not be same, right? See, A is a different array which is storing addresses. Okay. So A is an array which is storing addresses. A of 0 is a first array, right? So it is a different array. So this is like the array which Java is creating. We are not seeing this. So you'll never interact with this array. Okay. We'll interact with these arrays, which has the value. So this array does not have any value. This array just has the addresses, right? And we'll interact with these arrays which are actually storing the values. Okay.
So it means we cannot ideally present the base the base address.
Okay, let me just show you. Let me just tell you. Let me just show you all. Okay. See. Okay. Let's say this is our array that we created. Okay. So when we wanted to print a one-dimensional array, what we used to do? So we used to write a loop I equals to 0, I less than n, I plus plus. Okay. Now if I do the same thing, system.out.println, and I just do A of I. Okay. I'm not printing anything. I'm just printing A of I. Okay. Let's also do this and comment this one. Oh, see, this is not 10. This is 10. Okay. Let's run this. So we have 10 arrays, like how our 10 arrays should be there, right? So if you create 10 arrays and you print just A, B, C, D, E, F for 10 arrays, you'll see 10 addresses, right? So you have 10 addresses that is present for 10 one-dimensional arrays, okay, which are different, right? They are very different addresses. They are present. They might be adjacent. They might not be adjacent. Okay. The only point that I'm trying to make over here is that we represent it in form of matrix, but in actual memory, it can be a matrix or it can be multiple one-dimensional arrays spread at different places in the memory. That can also be the scenario. Okay. Now, what is this A that you are getting when you print A? What is this A you are getting? So since you created so many one-dimensional arrays, there should be some address books. There should be some array which is storing this all addresses, right? So when I say A of 0, 0. So what am I telling? From the first array, I want to access 0. So what is the first array? What is the address of first array? So there should be some address book which will be telling me what is the address of the first array. And this array is that address book. So this array is that address book which is telling me what is the address of the first array. When I try to print, like say a of 5, 2. So what I am doing, so I am telling, tell me the like value that is stored in the fifth array, array at index 5 at the position 2. So whatever is a of 5, let's say this is like 0, 1, 2, 3, 4, 5. So it will check, okay, this is the address of fifth array. Now in this particular address, I will just add like the normal calculation that earlier used to work, right? So if we get the base address of array, we just used to add this, right? The offset into the size of the integer, right? So base address plus 8. So this used to give me the address of that particular location.
Sir,
Yes.
sir, I have a small doubt, sir.
Yes.
So in the address we can see an square bracket.
That I guess like this Java compiler is adding just to
Yes.
differentiate between
Yes.
the other addresses and this address, right? So see, all the other addresses has a square bracket. So that is, I guess, coming from the operating system, which is giving the logical address like this. Or I guess
Sir,
actually the compiler is giving it like this, and Java is maintaining these two square brackets so that it's note that this is the address of the like one-dimensional array. This is the address of the base address of two-dimensional arrays. So that it can create multiple, in case of
Yeah.
multi-dimensional array, it can easily predict whether it is like the address of 1 dimension, 2 dimension, 3 dimension, or 4 dimensional.
Yes, that's what I'm asking, because we can see in the first printing, we can see the two opening brackets. So
I understood. I guess Java is using this way to differentiate between the like 1 dimension, 2 dimension addresses. So I guess this is the actual address which operating system is returning, and this is what Java is adding at the start to know whether it is the address of 2 dimensional array, 1 dimension, or 3 dimension, because we can create multiple dimensional array. Now, is our logic just limited to 2 dimension? No, we can actually create any dimensional array. 3 dimensional, 4 dimensional. So fourth, fifth, I honestly speaking, I've never used them, never required them. But 3 dimensional has uses when you will learn about dynamic programming. So there are questions that needs to be solved using 3 dimensional arrays, right? So for example, if you create like this, yes.
Sir, I have a doubt, like some in when in one dimension array you are printing a and a of 0, then both of their addresses were same. But like
so that was
why is it not happening?
I'll say that was just a coincidence when I printed it separately. So it was like just a coincidence because it was different iterations. Somehow it was getting assigned, right? So when you print it at the same time, it will always appear to be different, right? So that was just a coincidence when I was printing it separately.
Okay.
So see, when you do multiple runs, so that is a like new allocation that is happening. The same address might get allocated to some other array, right? So it might be like might happen, and coincidentally it happened twice when I ran it. But when you print it like this, you will be actually able to see the different addresses. Okay.
Okay.
Invent here address of a and a of no a of 0 is like a is the address of a of 0, right? A is the logical address of a of 0, but when you print a of 0 actually in a one-dimensional array, that will give you the value, right? So a and a of 0 address is same, but when you print a of 0, that gives you the value. When you print a, that gives you the address. Here also same thing. When you in a two-dimensional array, when you print a of 0, a of 1, it gives you the address of the like starting of that one-dimensional array. When you print a of 0, 0, this gives you the value, right? Same thing in case of two-dimensional array. Let's say if I print a of 0, 0, sorry, three-dimensional array. Now, what is a three-dimensional array? So how can you think of a three-dimensional array? So see, three-dimensional array is something like this. So we understood two-dimensional arrays is like you can think it like a matrix, right? So multiple one-dimensional arrays put together. So you have rows and columns, and each row column cell has a particular value, right? So let's say this is a 4 cross 4, 4 rows, 4 columns, right? So basically it is a 4 one-dimensional arrays, and each array has 4 values. Okay, 0, 1, 2, 3. 4 one-dimensional arrays, and each array has 4 values. Now here, each cell, earlier like in a two-dimensional array, this would be values actually. Okay. I'll slow down a little bit. See. So in case of two-dimensional array, this is what a two-dimensional array is, right? So you have values in each cells, right? You have values that is present in each cell, and these are representing values. Okay, let me just show you this. I did not show for values. Let's go up. So we created this two-dimensional array. this is addresses, right? So this is printing address. We are printing A of 0. So this is printing the value. How do we store any value in a two-dimensional array? So I'm telling in the first array, store at the first index the value 10. Okay. So this is how you can store, and this is how you can print it. Right now, if I print this, you get the actual value. So what I am doing? So whatever array I created, two-dimensional array, inside that, in the first row, okay, in the first array, or you can call it as the first row, in the first column in that array, in the first value, I stored this value 10, and then I'm printing that. So we are seeing 10 as the output. Okay. Now, in case of three-dimensional array, how the things would work? See, in the case of three-dimensional array, it is again very simple. In place of just these values, you are actually storing arrays. So these are not values; these are actually arrays. So you can think it like each cell is having an array. So each cell is nothing but an array. Okay. Which is having values. Okay. Now, okay. So let's think of this one. So what is this? Let's do this. So if I print A of 0, A of 0 of 0. Okay. So if I print this, so this would be actually pointing to a value which is 0. Okay. We are seeing the value by default. Any array cells have the value 0, right? So if you want to store any value in any array cell, so you have to do A of 0 of 0 of 0, and you store 10. You run this. You'll actually see that value 10. Okay. Now, what if I remove just this and I just print A of 0 0? What this would be? What does A of 0 0 represent? It's like a cube. Yes, you can think it like a cube, right? So what does this represent? This represents the logical address of this one-dimensional array, right? So this one-dimensional array has this logical address. Okay.
So can you please print the address of A in the three-dimensional array?
A in three-dimensional array, yes. So that would be also present. So that A is the matrix that would also print the address, and you'll see 3 square brackets. So that square bracket convention is correct, right? Then here you would see 3. If you print A of 0, so this is here you would see 2 square brackets. This is the address of this one-dimensional array, which is again storing addresses itself.
Yeah.
Okay. In 3D array, each cell is a one-dimensional array. So in 3-dimensional array, each cell is a one-dimensional array, right? So see, just think it like this. I might sound a little weird here, but think it this. So in 2-dimensional array, each cell was a value, right? Think it like a plain page. You create a matrix and you put values, right? In 3-dimensional array, each cell is having an array inside it. Okay, each cell is having a single one-dimensional array inside it. Now in 4-dimensional array, what it would contain? 4-dimensional array में क्या होगा? So ठीक है, 4-dimensional array would look something like this. एक तो matrix बना लेते हैं. Inside this, each cell, what this each cell would be? How this each cell would look like? Each cell would look like a 2-dimensional array. Okay. So inside, if you create a 4-dimensional array, it is nothing but a 2-dimensional array present inside each cell of a 2-dimensional array. Okay. What is 5-dimensional array? So 5-dimensional array is nothing but each cell. Each cell contains a 2-dimensional array. Inside this, there is a single 1-dimensional array. In 6-dimensional array, it would be again a 2-dimensional array. Then in 7-dimensional, again that inside 2-dimension, there would be 1-dimensional array. And you can change this as long as you want. Java doesn't give you any restriction that you cannot create 10 or 100-dimensional array. If you want, you can create it. Okay? Java gives you that comfortability. Now, do we ever need these? So you will never need these kind actually. Okay? This is like, how many of you have seen that movie Inception? Anyone? Yeah. So in that movie, there was like a scene where it shows, right? Inside a dream, there was a dream, and inside that dream, there was a dream. Same thing is there, right? So inside an array, there is an array. Inside that array, there is some array. Inside that array, there is some array. And in actually, there is no 2-dimensional array that exists in memory. There is only 1-dimensional array that exists, right? So you can think it like there is a 1-dimensional array, which again points to some 1-dimensional array. which again points to some one dimension array, and this is like very long chain, you can keep on chaining them. So this was like normal 1D array. Now when you have this is a 2D array. When you have this is a 3D array. When you keep on chaining, it would be a 4D array and so on. Understood?
So does it basically mean the last array would have the values and the other would store the address of the next array?
Yes. So it essentially means that. So when you have like last array would just have the values, and all the other intermediate arrays will have just the value. So for example, in case of 2-dimension array, so our actual array looks like this. So there is only 1-dimension array at the top, and each cell has the values. Okay, so each cell has these values. Each cell is just pointing to some value. So this is the last arrays, right? So there is no arrays below this. So these arrays actually have the value. So all these arrays, last arrays have the value, and these are just for storing the addresses. This first array just stores the address. Now in case of 3-dimensional array, so these arrays will have again multiple arrays within them, right? So each cell will point to arrays. So these all will just all these intermediate arrays will just be addresses, and the last arrays will have the values. Okay. So these arrays will have the values, and these intermediate arrays will nothing be just addresses. They will be just addresses. Okay. Now what is the use of this address? So without address, how will we figure out where the value is, right? So this is like, you can think like Java gave us one capability of creating arrays. Now what we did that and Java gave us one flexibility that inside that we can even store addresses as well. So what we did is we started to chain them. So inside one array, we started to store another array, right? Address of some another array. Inside that array, we stored address of some another array, and we can chain this infinitely. So for simplicity, like this is one of the most used arrays, chained ones, which is 2-dimensional array, and which has a lot of practical usage. So this 2-dimensional array you need in a lot of places. So for example, or any image that you see is nothing but a 2-dimensional array. Okay, any video that you are seeing, a lot of data in your front end, back end are stored in form of 2-dimensional arrays. Okay, so 2-dimensional array is one of the most common ways of storing data. Okay, and it's like the most naive way of storing any form of matrix data. Okay, understood? Clear? We are use 3D. Yes, and so any 3D kind of thing would be storing 3D like 3-dimensional data. Yes, so they will have a lot of usage of 3-dimensional arrays. Yes, so 3-dimensional arrays, these are arrays not just to show things. For example, image is a 2-dimensional array, but there are other uses as well. Right? So we use 2-dimensional arrays for memoization in dynamic programming, 3-dimensional arrays for memoization. So they are actually storing some data in some optimal way, which saves our computation time. So for that also we use them. Okay. There is no usage of base address or logical address. These are just things that might be asked to in interviews, or you might get, so let's say you will get a 3-dimensional array like this, and someone would have printed something like this. You would have options to print. It would print the values or it prints the addresses. So you just need to know what is actually printing, right? So this is like questions that you might get in your interviews, or you might get in the online rounds. So this theory is for there. So theory is like this is just theory, right? How it is stored, how it can be used. But to use 4D arrays, being honest, I have never faced any scenario of using 4D arrays. There are like very complicated dynamic programming questions where it can be used. Again, in 3D modeling, VR kind of things, there can be implications of 4-dimensional arrays. Okay, so there it can be used. OS ka revision ho gaya? Yes. So actually I had this in my 12th when I was studying C++. So there was like calculation of base address of array. We are given the base address, we are given some array positions, and we have to calculate it where the array will be stored. And and there also there was a so there was also a implication if the array is stored in the vertical format. So we used to call it as row order and column order. So there was one question I saw in the chat which asked, is the array always horizontal? No. So they can be in the row order or in the column order. So you call it as the column order. So if the arrays are stored horizontally, we call it as the row order. So this is like arrays are stored horizontally in memory. And the column order represents if the arrays are stored vertically in memory. Okay. Game development, yeah. So any complicated kind of thing, it would be used even in like normal software. There might be some complicated logic to write or some data to store where it can be stored in that order. But generally for that kind of storing, we have objects which are like better suited. Objects are easier to understand. Nested objects are easier to visualize. So nowadays we use objects a lot often instead of having 4-dimensional, 5-dimensional arrays. And objects also have a better access, same access time as arrays. In case there are like there are better access time as compared to arrays in a lot of scenarios. So like we use objects nowadays. But yeah, in some places like game development or VR, there can be no alternative to it. Okay, understood what multi-dimensional arrays, what 2-dimensional arrays, how it is stored in memory, how it is related to 1-dimensional array, what these addresses represent. All these concepts are clear. Yes. Okay. Okay. So now you can think it like you understood arrays. Now you got a flexibility that you can create arrays inside arrays. Okay. So like for example, whenever we saw something, right? So we saw instead of like if this topic was named as nested arrays, it would have been so easy for you all to understand, right? So you saw nested if. So what does nested if mean? What does nested if mean? So if inside if, right? What does nested if? If inside if, right? What does nested loop means? Loop inside loop, right? What does nested array would mean? Array inside array. So earlier we saw that arrays are just capable of storing a single value, but instead arrays are also capable of storing other arrays. Do they actually store other arrays? No, they just need to know the logical address of other arrays. If you have the logical address of any array, you can access the entire array, right? You just need to know the logical address of the start of the array. Okay. Just change the name, it got simpler without any explanation. Yes, that's the way to. From next batch, we'll name it as not 2D arrays, we'll name it as nested array. Okay, so students will automatically know it is just array inside another array. Okay, now let's see what are the questions to in this thing. So okay, so the questions that you'll see is like mostly related to this grid kind of thing, where like we see this arrays grid. So let me just show you what I mean. So let's say we have this. We can even create this 2-dimensional array like this: 1, 2, 3, 1, 2, 4, 3, 4, 5, something like this. Okay, so we created a 3 cross 3. Actually, let's create a 3 cross 4. 4, 5, 6. Okay, so this is how we used to store arrays, right? So inside a single curly bracket, each cell used to be a value. Each place used to be a value. Instead of that, I just stored a like array inside it. Yes, Excel sheet is just a 2-dimensional array. Yes, that's the best example. Your Excel sheet is just a 2-dimensional array. Okay. Let's now try to find out this. So let's say int n is equals to a dot length. Or any table, right? Any tabular form of data is the 2-dimensional array. I'll explain on the questions. I'll come to the questions. Okay, so this array has two things: rows and columns. Okay, so we have like what does a of 0 represent? A of 0, so see, what does a represent? So a is the array. What does a dot length represent? So a dot length represents how many rows you have, right? Now, is it clear? Now, does it make sense why a dot length represent the number of rows? So what was a array? So a array was the array that was storing the address of other base address of all the other arrays, right? So here there are 0, 1, 2, 3. 0, 1, 2, 3. Right? So 0, 1, 2, 3. So this is storing the base address of other arrays, and this is just a array. What does a dot length represent? A dot length represents how many 1-dimensional arrays you have or how many rows you have, right? Now, what does a of 0 represent? A of 0 represents simply how many values what is the size of this array? How many values you have in this a of 0 array, right? What is the size of this array? Now, can they be different? Okay. So generally you would see that this is a like matrix kind of thing, but it is actually, it can be flexible. Let me show you this. So for example, let me just print this. So so how do we print this array? So first array runs for like here, like how many rows you have. So how many rows you have? N rows. Okay. Now how many columns you have? So so you have these many columns, M columns, right? Okay. So M column basically how many values you have in each row. And we can print A of I and A of J. So this prints all the values in any array. So, okay. So for it prints the values in the ith array. Okay. So it prints all the values in the ith array, and then let's change the line. Okay. Now if I run this, see, so this is the first array, 1, 2, 3. A of I, when I is 0, I'm printing all the values in the first array. When I is 1, I'm printing all the values in the second array. When I is 2, I'm printing all the values in the third array. I is 4, I'm printing all the values in the fourth array. Okay. I got all the values in each of these arrays. Now, one simple question: can the sizes of can the number of values each of these arrays storing can be different? Yes, it can be actually different. So you can store 5, 6 values in the first array. Okay, 2 values in this array. So that is possible, right? Now, will you need to do this length over here? No, actually, you need to find out the length then over here. What is the size of A of I? Okay, now if I run this, let's see, this is also working fine. Okay, see. So the first array is having like, so how is this array actually, right? So how this array is actually present? So the first array, A array. Okay, when you A array is storing addresses of 0, 1, 2, 3. Okay, let's say this is address 1, address 2, address 3, address 4. Okay, what is address 1? Address 1 is nothing but base address of some array. We call this address as the base address. Okay, it's for simply we refer it as base address of the array. So this is the base address of array, which is having 5 values. Okay, so this array has 5 values: 1, 2, 3, 8, 9. Okay, this is the base address of some array which is having 3 values. Now, since they are multiple one-dimensional arrays which has nothing to do with one another, their sizes can be different. Okay, this is the array which has a base address, and this has 2 values, and this array has a base address which has 3 values. Yes, this is known as jagged array. Yes, so this is also known as a jagged array which has different values in each of these. Each arrays inside this arrays are having different sizes, right? So generally you will never create arrays like this because there is very few uses of them. The most of the time you create arrays which are having the same column. For 3-dimensional array, can we find the third length by A of 0, 0 dot? Yes. So the last array's length is A of 0 dot length. Yes, so that is going to give A of 0 is the one-dimensional array, right? So if you do dot length, it is going to give you that. Okay. So what is jagged array? See, so jagged array is nothing but when we are creating array, so we are creating multiple one-dimensional arrays, right? Now, can these one-dimensional arrays have different length? Yes, they can have different length as well. Okay, so see, so these arrays are actually having different lengths. Now, when we create arrays like this, so they are having different lengths where each array has its own length. Okay, now how do we find out the length of each of these arrays? So we just need to do that array's address dot length, right? So it is the address of this array, A of 0. So if we do A of 0 dot length, it will tell me what is the length of this array. If I do A of 1 dot length, it is going to tell me what is the length of this array. What is the address of this? A of 2. So A of 2 dot length, if I do, it will tell me what is the address of this array, so on. So if you just need to do A of I dot length, it is going to tell you the address of that particular array. Okay. Understood? Now, can we create this kind of jagged array by having user input? Actually, we can. Okay, so there is one way. So first, tell me, understood this one, right? When we created multiple arrays of different lengths, there is no usage of it. So generally, you would create arrays like this. Okay, so your arrays would have the same length, and it would look like this. Okay, so if we run, so all the arrays would have same length, same number, like rows numbers will differ, column numbers will be like same. Okay, so generally your arrays would look something like this, where each array, which each one-dimensional array has some fixed number of values, like 3, 4, or something. Okay. A dot length is giving 4, right? A dot length is giving 4, which is the number of arrays you have, right? Which is giving 4. This is the A array. Now, A of 0 dot length is giving the length of this first array. A of 1 dot length is giving the length of the second array. Okay, understood? Can we take these kind of arrays from user input? So now you can take your normal array from user input. How do we create an array which we want to take as user input? So let's create a 2-dimensional array of 3 rows and 4 columns. Okay. Or let's say 2 rows and 4 columns. Okay. So we can do this. A of 0, I is less than n, I plus plus. Okay, what is n over here? We can just do n is equals to a dot length. And m is equals to. So we generally do this a of 0 because this is always like in form of rectangular array. They're not jagged. Oh, yeah. How we can take you from user we can take, yes, that's what I'm saying. What is jagged array? So array of uneven, jagged array is an array. Okay, let me write that definition over here. Okay, so let me write this. So what is jagged array? So this is basically a 2D array where each row has different number of elements. Okay, understood? Now let's say if we create, so this is the example of chat where this will have 5, some might have 2, some might have 3, some might have 4. So this is the example of jagged where each arrays might have different columns. It's columns, right? Different number of each row has different number of elements. So each array row has different numbers of elements, right? So first row has 5 elements, second row has 2, third row has 3, right? So that's correct. Okay. So now here, how can we take as input? So you can write a of ij is equals to sc dot next int. Now, if you run this, you should be able to see the array inputs. Okay. Now let's give some input 1, 2, 4, 5, 9, 1, 2, 7, 8. Okay. See, so this is the input which you are taking. Now, why did I take a of 0? Because here I have given that the number of rows is 2 and the number of column is 4. I have fixed them, right? So there are 2 rows and 4 columns. I'm not changing. Each row is not having different number of columns. So you can simply find out for any array. So that is going to be fixed, right? So for a of 0, 1, it's fixed. So a of I, okay. So this is like a common way to take array inputs and it's a common way to like find out the length of the columns. Let's run this. I'm telling about how will you take input if the column numbers are different. Okay, see. So now when the column numbers are same, this is what you'll do, right? So this is your 99% of arrays where you will have same number of columns in each array. So this is like your matrix, right? So you have matrix where you have multiple rows. You can have as many rows, and each row like has same number of columns. Okay. Okay. This one I guess you would have seen, right? The time where we need to input number of rows and columns. Yes, you can give this number of rows and columns, right? So these two values can be user input as well. So you don't need to give them. If there are user inputs, you can create array of n cross n size. Yes, that's fine. Any shortcut to write? I'm also trying to figure out. So actually, at least it's not here in this compiler. I guess someone suggested system.out.println s.o.pln, but that doesn't work, right? Sometimes just writing like println, sometimes write sit, but that also doesn't work every time. So this is like something which is broken in this. Cout is better. No, this is not mostly in lead code. All the questions that you will see, I'll say 99% questions have fixed rows and fixed columns. Okay, if there are like variable rows and columns, that's a very rare question. Okay. In the compiler we can add that. Yes, that we can do. We can see a snippet of then println. Yeah. Okay. Eclipse is better for fast. Okay, chalo, we'll bear with that. Apart from that, it gives the output super smooth. So that is the only reason I use it. It's like super fast. And everything is there in this page itself. So I don't have to switch context. Okay. First, tell me, understood this, how you can create, how can you create an array yourself by giving values, or how you can take this input from user, right? Fine. Achha. Now, can we do this for varying size? So this is like just I'm showing you, don't get confused, right? So I'm just trying to show you. So don't forget this, because this is your 99% cases. Okay, so don't mix with this. Why a of 0.length? See, why did I take m as a of 0.length? Because m number of columns we have fixed, it is 4, right? So you can take a of 0, a of 1, right? Any valid row index that you can pass, you can take any valid row index that is going to be fine, right? Even if you take a of 1, that is also fine, because a of 1 is also a valid row. So that index is also fine. Okay. Okay. Now here, how do we create this varying array over here? So what you need to do is you actually just need to pass this row numbers. So how many rows you are going to have? Let's say I'm telling that I'm going to have 3 rows. Okay. So what does a dot length is going to give me? A dot length is going to just give me 3 rows. Okay, let me just show you this. Let me comment this. So if I just pass row, will I be able to create arrays? So if we do system.out.println a, run this. See, we actually see some address. So the array is actually created, right? If we print n, it will tell us how many values this array has. Okay. So it is telling 3 values, right? So if I write a of 0 and I run it, see, it is storing null. So we have created actually an array of 3 size, right, which is storing this null address, because we have not stored any addresses, we have not created this array. If I give it some value like over here, so it will actually create 3 arrays of 3 sizes, and these will point to those addresses, right? So when you run this, you see the address. Why you see the address? Because now the arrays are created. So okay, let me show you visually. So when I do this, what is actually happening is this is the first one-dimensional array, right? And this is pointing to some one-dimensional array, which is also created of 3 sizes. Okay, and there are 3 actual such arrays which are created, and these are pointing to these addresses. So that's why when you print a of 0, you see the address of this array. When you print a of 1, you see the address of this array. A of 2 prints the address of this array, right? No, it should not be 0, because 0 is the values which are stored in these arrays, right? Now, this is the address array, right? When I don't pass this, so what is this array storing? So actually what this array should be storing, this array should be storing addresses, right? This is not the value array. This array is storing addresses, right? So in case of when the array should be storing values, the default value is 0. When the array stores addresses, the default value is null. So that's why we are seeing null. When you run this, you would see null in case of this. Okay. So these are like output questions, or these are like questions that are asked in interviews, what we would see over here, right? So let me write it like this. So when you have values, the default is 0. When you have addresses, the default is null. Understood? Now, so we can dynamically allocate. Yes, that's what we can do. So let's say now actually we want to create this array. Okay, So we already have created this array, but this is not pointing to some array, right? This should be actually pointing to some arrays, but it is actually not. Okay. So can we create this multiple one-dimensional arrays ourselves and put them over here? Can we do that? Yes, we can do that. Okay. So a of 0, 0 is not going to have anything, right? If you just try to, okay, that is a valid question. So let me do that first. So when you try to print a of 0, 0, so that is actually going to give you index out of bounds. Okay, because this is not a valid array. Okay, null pointer exception, yes. So you're trying to access something which is not present, so you're getting a null pointer exception. Okay, so you're trying to access a value of null which is not present. Okay, so this is going to give you error. Now coming over here, can we create this different arrays? Yes. So what does a of 0? What does a of 0 should store? A of 0 should store a array. Now can we store some array over here? We can give new int. Let's say we want to create an array of I plus 1 size. Okay. So for 0 index, we want to create an array of 1 size. For 1, we want to create an array of 2 size. For 2, we want to create an array of 3 size, varying sizes. Okay. Now if I run this, so there is some m. Okay. So this should be I plus 1. M is the length is I plus 1. N is fine. And we already know. And then we can print this. Whatever in okay, sorry, m we don't know, right? So here also it's error. It is int m is equals to a of I dot length. Okay, see, so let's say first array, what is the size of first? So we created one two-dimensional array which has 3 rows. Okay, 3 rows we have already stated. How many values that each row have? So in this first row, we are storing I plus 1, which is 0 plus 1, 1 value. Okay. So first row, we are storing 1 value. Let's give it as 1 input. Second row, we are storing 2 values. Okay. So let's give 2 and 3. Third row, so did we access something? So we created 3 rows, I plus 1. Oh, sorry, this I have mentioned as I. This should be a 5. Yeah. Okay. So the first row I am storing 1, second row I am storing 2, 3, third row let's store 5, 6, 7. Okay. So this is how your array looks like, right? So we created multiple one-dimensional. So we created a two-dimensional array where each one-dimensional array is storing a different length of array. Their array length are not same. So this can also be done because those are like one-dimensional arrays. We can create any size one-dimensional array. We can just store them. We just need to give them some like row index. What if we don't even give the row index? Can we later give it some different address? So this is basically actually not doing anything. So this address, this is actually not given creating any size array, doing nothing. Okay. So this you should at least give one row address so that later you can create multiple one-dimensional arrays and put it there. Understood? How can you create multiple one-dimensional arrays of varying length? See, okay, let me explain this once again. So, okay, firstly, what I did, I told that don't get this like inner arrays. So this, what is the size of, what is this size telling? This size is telling what is the length of inner arrays going to be. Right? So what is the length of this arrays? Whatever this array is containing, what is the length of that going to be? Right? So we are not telling that. We are not telling that whatever is the length of this arrays. We are not telling them. We are just telling that this is going to be of 3 length, and the inner arrays we don't have any idea. So we are not telling this size. Okay. Now, okay. So this is fine. Now inside here, what we are doing? See. A very even size, not following a pattern. Then if you want to create an array like a very even size, not following, so you can create, right? You can take this input as user input. What is the length of first array as user input, and then create array of that size, right? So it is just like you can take user input, create of that size. Okay, so this is like not a pattern. I just gave it like some varying length. Instead of I plus 1, we can take user input, right? That's fine. Now, here what I did, I told that for first a of 0. So when I loop is running for I equals to 0 for the first array. Okay, first array. So what I did, I created an array a of 0 is equals to new int. What is I plus 1? I plus 1 is 1. So I created actually an array of 1 length. Then I actually took the input a of 0, 0. So this is 1 length. So this runs once times. So I take the input, which is a single value. So I took a single value as input. Okay. Next time this loop runs, I'm creating a new array of a of 1, which is new int, and I'm giving it a size 2. So what this is creating a 2 array of 1 dimension, which is pointing to. Why a plus 1? I just took some varying length. You can take this as user input or whatever you want, right? I just was trying to take some variable inputs. Okay. So first iteration it is going to be 1, second iteration is going to be 2, third iteration is going to be 3. So our array lengths are changing. Okay. It necessarily does not has to be I plus 1. You can take it as complete user input M, and you can create array of that size. Okay. So basically you can do it like this. Int M is equals to sc dot next int, and you can create array of this size. And that is also fine. So whatever is the user input, your array size will be that. Can we make a boolean to keep the taking? That you can do, right? So you can check for user input, and if the user input is equals to certain value, like let's say you are taking G, so if that is the user input, then you can stop taking the inputs. Okay. Or you can take it like enter -1 if you don't want to take any user inputs further. So that also you can do. Understood? Clear? So now you can create 2-dimensional arrays of fixed sizes. You can create it of varying sizes. So this has very less applications. You're like I'll say none of the questions are going to be like this. All the questions that you're going to get will have like same rows and same columns, and it would be in form of a matrix. Okay. So we'll focus on this kind of arrays, and we'll see how. Let's go to questions. Yes. So let's see a few questions now. Enough of the theory. So this is what 2-dimensional arrays. This is what you should know about 2-dimensional arrays. What these things print, what these things mean. What is the default value of address that you're going to see? It's null when you don't have any addresses, when that doesn't point to anything. For example, like this. When you don't have any addresses in the first 1-dimensional array, so it would give you null. Okay. Okay, that's it. Right. There is one thing like this would be interesting. I'm also not sure what this is going to result. Might throw error. Might be null. Okay, so now if I create this and I run this and print a dimension missing. Yeah, so this is telling us a dimension missing, right? So this is like this is not allowing us to create an empty array like this. It is telling we should at least keep a row index. Okay, we can skip the column index because it knows that once we know the row, we can later give addresses to that. Anyways, it is going to create multiple 1-dimensional arrays, so it is not mattering to it whether we create it beforehand or we create it on the runtime. Anyways, it's going to store in heap, so in no scenario is going to matter to this. Okay, understood? Okay. Okay, so now there can be like questions like, okay, let me tell you a few questions. Or let's take one array as example, on which I'll be solving this question. Let me take this one for simplicity. We give value in column, it will create vertical arrays. No, it will never create vertical arrays. The like arrays logically will be created horizontally. You can treat it as vertical arrays. Okay. Like we can try to. Just a second, give me a second. Sorry. So we can we can think it of vertically, we can do it printed. Okay. So let's see questions, right? You will be easily able to understand this. So see, what is this? So this is like the horizontal array. How do we print it? So the simplest way to print them is find out the rows, number of rows. How can we do that? For finding out the number of rows, you can simply do a dot length, which will give you the number of rows this array has. If you do m is equals to a of 0 dot length, that gives you how many columns this array has. Okay. Now if I run a loop, that will run for I equals to 0, I less than n, I plus plus, and for int j equals to 0, j less than m, j plus plus. Okay. System dot out dot println a of ij. So what is this going to print? This is going to print the row wise values, right? So value in each row. So first row we are going to get C. What does this do? So what does this do? So we are doing is, firstly we are going to all the arrays. A of I is telling me the array number 0, array number 1, array number 2, and inside each array I'm going through all the columns. So I'm printing the values of all the columns. So if I run this, it will print 1, 2, 3, then 1, 2, 4, 3, 5, 8, and so on, right? So it prints the array. Okay. Now, can we print the arrays? So this is like, let's say this is the row wise printing of the array. Can we print the array column wise? So can we print 1, 1, 3, 4, then 2, 2, 5, 6, 3, 4, 4, 7? Yes. How can we do that? So when we want to print the column wise, array in the column wise order, so what we need to do is the outer loop will run for the number of columns we have. Since the number of column is fixed, so we can run the outer loop for m times. Okay. Outer loop is going to run for m times, which is the number of columns that we have. The number of columns is 0, 1, 2. So there is like, so the column is 3. So we are going to run for values 0, 1, and 2. How is the inner loop going to run? So the inner loop is going to run for the values j equals to 0, j less than c. For the outer loop is running for the number of columns. Inner loop for each column we are going to print. So for column number 0, we are going to print all the rows. Okay. So we can do inner loop is going to run from 0 to it. Now what do we print over here? What is the row number and what is the variable storing row and what is the variable storing column? So inner loop is running for the rows, right? Inner loop is running for the row, right? Which variable? J is running for the rows, right? So J is the row. And what is the column? I is the column. So this is it. Now if I run this, see the difference. So this is the actual how it is stored in memory. This says a lot about it. This is just like we have tweaked it and we have printed it in the column order fashion. So you see the first column getting printed first, so 1, 1, 3, 4, and then the second column 2, 2, 5, 6, and then the third column 3, 4, 4, 7. Yes. And this is also the transpose of the like matrix that we printed initially. So this is also the transpose of it. This is also the I guess this is not any rotation. I guess this is not a rotation, but this is the transpose of the matrix. This is the column order. So there are two questions in the assignment. One is print the transpose of the matrix. This is the same solution, and one is the print the matrix in the column order. This is the same solution for that as well. Okay, understood? Doubts? Yes, no? Clear? There is one more question. Can we do a rotation on this matrix? So let's say, see, every time you get a rotation question, you just have to figure this out. So in this question, let's say I give you to rotate it by 90 degree towards left. Okay. So how does this rotating by 90 degree towards left it will look like? So this will become the first row. So if you rotate it, like think it like a paper, just write these values in a paper and just rotate that paper by 90 degree. So you'll see this would be something like this. Is this how it is going to look like if you rotate it by 90 degree towards left? Yes. Okay. Now see what it is. So if you are asked to print this, okay, it can be rotated by 90 degrees towards left, 180 degrees towards left, 90 degrees towards right, 180 degrees towards right, or 270 degrees towards left. Anything it has asked. Okay. Whatever it has asked, you just need to figure out. So what is this first row that you're seeing over here? What is this first row in the initial matrix? What is this first row? So this first row is nothing but the last column. So I can say you just have to print the last column first. Okay. So if I ask you to do this, you just need to print this value, right? You just need to print the last column. So if the column index is fixed and row index is changing, so your I will run from. So this loop, let's say, so column index is fixed. Okay. So let's say I want to print something for which the column index is fixed. What is the last column index? What is the column index of the last column? Yes. Okay, paper thing. Chalo, how many of you have a paper with you? Diary? something like that. I have a diary with me, but I don't have a pen. Yes, I have a pen as well today. Chalo, I have a pen. I got a diary from company, right? So I got it few days back. So let's use it. So let me write it and let me know if you are able to see it. I'll write it to it a little bit bigger. 1, 2, 3, 1, 2, 4, 3, 5, 4, 4, 6, 7. Okay. Let me know if you are able to see the numbers. Is the numbers visible? Yes. So this is how your array looks like. Not. The focus is very bad on this camera. Yes, I can see that. Okay. Then I might need a marker which is not available with me. Right? Let me know if you are able to bear with this. So this is like the numbers, right? So we have some numbers that's there. Now, when I rotate this, how it looks like. See, the numbers are tilted, right? So that just ignore that. But you are seeing something like, say, this is 1, 1, 1. So this is what you have to do, right? So you just can like look at this. So this is your original array. Just rotate it by 90 degrees. This is how it looks like. So same thing you can try out. So this is what I was telling. This is what it would look like, right? See. So this is your initial array, right? So what I drew initially was, it was something like this, right? So it is something like this, which is your initial array, right? This is your initial 2-dimensional array. Now I did a right rotation was 90 degree. 90 degree, I rotated it towards right. So just write it, these numbers on a paper, rotate that paper by 90 degrees. So if your paper is something like this, just rotate it by 90 degree towards left, which is should be like this. So then you should be able to see the matrix in this order. So this should be your values. 3, 3, 4 will go at the top. This would become the middle row, and this would become as the last row. Okay. Now just tell me what's the index of this last row in terms of NM. So there it is 0, 1, 2. So what is like can you tell it in terms of M, N, something like that? So if there are if the number of columns are M, so what is the index of this last row, last column? It is M minus 1, right? So if let's say N is the number of rows and M is the number of columns. N is the number of rows, M is the number of columns. So the index of the last one is M minus 1. What is this? What is the column index? Column index is M minus 1. Yes. What's the row index? What is the row index? Row index is varying. Actually, see, row index is varying 0, 1, 2, 3, 4. Right? So we need to vary the row index from I to N. I don't need to do I plus. Now, if I run this, you would actually see this is printing the first. Okay, I forgot to write I over here. Let me run this. So you're seeing 3, 4, 4, 6. Okay, let me print it in the same line. Instead of doing this. Let me run this. Let me comment this out. Okay. So see, what you are getting is you are getting the last column of this matrix. See, you can print any column of the matrix. You just need to when you want to print any column in the matrix, what you need to do is you just need to fix the column number. Your rows will vary from 0 to N because you have N rows. So you need to just vary the number of rows. Your column index are fixed and it will print the last one. See, so for example, here the last column's index is M minus 1. So I tell that column index is fixed, which is M minus 1. I need to print all the rows inside in this column. So the row is starting from 0, 1, 2, 3, 4. It is varying from 0 to 4. So these are all the rows and this is the value that I am getting. So I'm getting 3, 4, 4, 7. Understood? So how can you print any column? If you want to print the first column, what you need to do? You just need to fix it to 1. Right? So you'll see 2, 2, 5, 6. Yes. Okay. Understood? How can you print any column in the matrix? So you just need to fix that column index. Your rows would vary. If you want to print any row in the matrix, right? So let's say you want to print just any row in the matrix, what you need to do? So row is easy, right? Because we have stored it in terms of rows, so that is easy to visualize. You need to run a loop for the number of columns or the M, which is the number of values that you have in that particular row, right? And you just need to run for like you fix that row. So your row index is fixed. Let's say you want to print the first row, which is 0th row, and you just change the column. Okay, done. So this will print the 0th row of the matrix. See, so what is the 0th row? 1, 2, 3. So that is the value that you are seeing over here, 1, 2, 3. Okay, if you want to print the first row, so you just need to fix the row index, which is 1, and you just need to tell change the column index. Okay, understood? Okay, first you tell me understood how we can print each row, each column in the matrix. Now you can be given to print any row, any column in the matrix. You just have to print like for rows, you have to fix the row index, vary the column index. For column, you have to fix the column index, and you just have to vary the row index. How to access the element? Access the element is A of ij, right? A of ij. Spiral matrix question I'll not solve today, right? That is something you need to think at least one day, right? Then I'll solve it. Okay. See, so now in this question, let's come back to here when you are asked to rotate it by 90 degree. Okay, and I'm doing this. What this is giving you? This is giving you the first this last column, which is this first row of output. Okay, if I do it m-2, what you are going to get? This second row, 2, 2, 4, right? If I do m-3, what you are going to get? One. Yes. Okay, so and you need to print all the 3, right? So what do we do? How do we find it? So you just need to run an outer loop that will vary for this. So just write outer loop j, which is going to be from j is going to start from m-1. J should be greater than equal to 0. J minus. Done. Now if you do this j, run this. I forgot to give a println. You can go system.out.println. See, we are seeing the same result that we should be getting while after rotating this matrix by 90 degree. 3, 3, 3, 4, 4, 7, 2, 2, 5, 6, 1, 1, 3, 4. So see, what we are doing is every time you need to rotate a matrix, right? So you'll be placing some row at the start, some column at somewhere, right? So something would change. Now, if I just give you to rotate not by left towards 90 degree, just rotate it right towards 90 degree. So how does a right rotation towards 90 degree will look like? Let me just show you. Okay, let's do a right rotation towards 90 degree. Now this time you all figure out whether you will be able to do this one or not. So let's say I'm rotating right by 90 degrees. So how this will look like? So after right rotation, so this 4 will become the first value. So this will be 4, 3, 1, 1. 6, 5, 2, 2. And this will become 7, 4, 4, 3. Achha. Now tell me what is this 4, 3, 1, 1? Which row or column in the initial matrix is this? So 4, 3, 1, 1. This is the first column in the matrix. Okay. Now first column, are we printing from so first column. So if column index is 0. Okay, first column. How is the row index varying? Sorry, this is the column index. Sorry. So this is the column index which is fixed. So column index is 0. How is the row index varying? So row index is varying from, is it 0 to n-1 to 0 from the last to first, right? So it is, so this is varying from n-1 to 0. Done. Did you get the first output? Last to first, right? It is varying from last to first. See, not is 0 to n-1, it is n-1 to 0. Just the reverse. Okay. Same way we are printing column by column, just that this will run in the reverse way. Right. So in case of columns, when we are printing it column by column, we are running from 0 to n. Here we just need to run it from n-1 to 0, greater than equals to 0, j minus. That's it. Now, how is the what is the next row? This. The next column is, this is going to vary from 0 to m. Understood? So this loop, this would be the, and this is the outer loop, and this is going to be the inner loop. Now can you do all the rotations? Any kind of rotation, 90 degree, 180 degree, 270 degree, 360 degree, any kind of rotation is there. 360 will make the same matrix, right? So there would be not any question of 360 degree. But yeah, 90 clockwise, anti-clockwise, 180-degree clockwise, anti-clockwise, or 270-degree clockwise or anti-clockwise. So this would be like similar to 90 rotation. So let's see this. See, firstly, tell me, did you understand how these two matrices came up? So this is like the first matrix is a left rotation by 90-degree, which you can say anti-clockwise, and this is the clockwise rotation by 90-degree. Okay, just try to do this on the same matrix. If you're still not able to visualize this, like agar visually nahi dikh raha, so try to do one thing, just write this matrix in a piece of paper. Try to rotate it by left towards left by 90-degree, or try to rotate it towards right by 90-degree. Like you'll be able to see these two matrices. Okay. Now, sorting is sorting is there, right? Sorting is there in the module itself. So we have separate classes for sorting, and that is there in this module itself. I guess it is after 2D arrays. So after 2D arrays, we are left with two concepts. One is sorting. I'll take like 2 classes to complete this, and then there is strings. Okay. So don't worry, sortings and strings are going to be in very detail. Okay. Array list is also there. Okay. So now when you are rotating any array by 90 or any degree, right? So you just need to firstly find out the output. Once you got the output, let's focus on this one. Okay. So let's take this one as this one for which we wrote the logic. So what is this output coming from? So what is this first row? Just observe what is this first row in this output. First row in the output is nothing but the last column of the initial matrix. So you just need to print is the first row, second row, third row, and so on. Okay. If you just print it, you are having the result. Now, how will you get the first row, second row, third row, and so on? The first row is nothing but the last column of the matrix. The first row is nothing but the last column. What is the last column in this matrix? How do we get it? So in order to get the last column in the matrix, we just fix the column index, which is m-1. What is varying? The row index is varying. Row index is changing from 0 to n. Yes. So how did we write this loop? See, inner loop is changing 0 to n. So the row index is changing from 0 to n. And the column index is fixed, which is m-1 in the first iteration of J loop. Okay. So we'll get this value. Now in the second iteration, J will become m-2. So this will become m-2. And this is again going to run from 0 to n. So what you are going to get? So J is going to become m-2. You are going to get this one, which is the output. Fine. So column is varying from m-1 to 0, and the row is varying from 0 to n. So the inner loop is row, which is varying from 0 to n, and the column is varying from m-1 to 0. Okay, understood? Similarly, you can find out so here, so if similarly, if you see this, what is this? So this is like again the row index. Row index is varying from n-1 to 0. See, now here the row is varying from n-1 to 0. Bottom to top, we are printing the rows. See, 4 3 1 1 6 5 2 2 7 4 4 3. So we are printing from bottom to top. So here n-1 to 0. Row index is varying from n-1 to 0. So here like row index is n-1 to 0. And column index is varying from 0 to m-1. So the firstly you are printing 0th column, first column, and second column, and so on. Now understood? Any kind of rotation, simple. Just see it. You don't need to remember any logic. You just can think of like which index you have to print first, which one you have to print last. Your loop will run in that order. That's it. Okay. Let me write it. So this is anti-clockwise, right? Anti-clockwise rotation by 90 degree. Yeah. Okay. You can print any row, you can print any column in the matrix. So let me tell you one last concept on this. What is the break time there? Shall I give you break now? I just need one last column. Boundary wala kaise ka? Boundary wala main hint de dunga. Okay, I'll give you hints on the boundary question. Try that today. If not, then I'll solve it tomorrow. Okay. And then we'll solve array addition, subtraction. Okay. So let's go quickly, have your dinner, come back. We'll continue this. Okay. 15 minutes break. Hello, everyone. Welcome back. Happy dinner. And that's like the first time I've seen someone writing happy dinner. Okay. So okay, so let's discuss complete this 2D arrays. I'll give you some more ideas about what are the questions that you are going to get. So what's the next thing? Okay, let me print this array. Okay, 2-dimensional array. Okay, so now this 2-dimensional arrays can also have things like diagonals. Okay, so can be diagonals in this 2-dimensional arrays as well. So what are these diagonals? Look at this. So this is like the first diagonal, this is the second diagonal, this is the third diagonal, this is the fourth diagonal, this is the fifth, this is the sixth. So there can be multiple diagonals in this arrays as well. Right, so this is like from left to right. There can be diagonals as well in the right to left question. So for example, these can be also diagonals in the array. Okay. Now you would be given questions like so we call this so actually okay, so this is like for a non-square matrix, right? So this is a non-square matrix, so there can be like diagonals like this for a square matrix, right? So let's say this is a square matrix, 1 2 3 4 5 6 7 8 9. So here this is like one diagonal which we call as the left diagonal. This is one diagonal which we call as the right diagonal. So these two diagonals are basically the two left and right diagonals of any square matrix. Now you might get questions like find the sum of the left diagonal, find the sum of the right diagonal, print the left diagonal of the square matrix, print the right diagonals of the square matrix. There is even one question where you are asked to print all the diagonals of a given matrix, right? So how you can do this? So let me just write this. So write this matrix in the index form. So this is 0 0 0 1 0 2 0 3. How is this a square matrix? Okay. So this is a square matrix. This is not a square matrix. This is a non-square matrix. This is a square matrix. 3 rows, 0 1 2. So there are 3 rows, 3 columns, 0 1 2. So any matrix having like 3 cross 3, 4 cross 4, right? 5 cross 5. These are known as square matrix, where the number of rows and number of columns are equal. Okay. Now look at this. So 0 0 0 1 0 2. This is like the first row. Second row 1 0 1 1 1 2. Third row 2 0 2 1 2 2. Okay. So this is a square matrix of 3 cross 3. So let me create a 4 cross 4. 0 3 1 3 2 3 3 1 3 2 3 3 3 4. Okay. So this is a 4 cross 4 matrix. Okay. Now over there. So again, look at this. So here what we have is this is like okay, sorry, 3 0. Sorry. 3 0 3 1 3 2 3 3. Okay. So now what is this? What is this diagonal? What is the similarity between index values of these diagonals? What is the similarity over here? So if I ask you to print just the values at this diagonal, what is the similarity? So I is equals to j, right? What is the similarity in this diagonal? What is the similarity in the index values of this diagonal? Any similarity do you see? 0 3 1 2 2 1 3 0. I plus j is equals to n minus 1, right? So this is one similarity that you can see. I plus j is equals to n minus 1, right? That's it, right? So now if I ask you to print any diagonal in a given matrix, so let's say this is a non-square matrix. So let's make it a square matrix, 3 cross 3. Okay. Now if I ask you to print the left diagonal, how can you print it? 0, I less than n, I plus plus, for so so it is a like n cross m matrix. So this is like here n and m are same. So n cross n matrix. So n is just the size of matrix. Okay. So you can check if I is equals to j. In that situation, you have to print system dot out dot println a of ij. Otherwise, we don't do anything. Now, if I run this, so this is the matrix and this is the left diagonal 1, 2, 4, right? Which is fine. 1, 2, 4 is the left diagonal. What is the right diagonal? For right diagonal is just that y plus j is equals to n minus 1. Okay. Now, if I run this, you should be able to see the right diagonal. Okay. 2, 3, 4. So like 4, 3, sorry, 3, 3, 3, 2, 3, 3, 2, 3. Yes. So this is the right diagonal. Okay. Now you can be asked to print any diagonal. There is one question which in the assignment, right, where you have to print all the diagonals. Okay. From left to right, right to left. I'll just tell you in the reverse order, right? So there is like this, yeah. If it doesn't matter, like for this particular question, it doesn't matter whether it is uneven, equal size. Right. For 4 cross 3, there is not going to be any left or right diagonals. There would be any. So for example, if this is 4 cross 3, so it would be some diagonal would be like this, right? So if this last column is not there, okay, let's say this ends over there. So this will be the left diagonal, right? Which doesn't touch the right bottom. So left to right bottom, it won't be there. It would be till here, right? So there it is like not the exact. So when I say left and right diagonal, so it means that it's starting from top left, ending at bottom right. So that is just for square matrix. For non-square matrix, it's not going to happen. Okay, see, yes, I'm just telling that how is this I plus j equals to n minus 1 coming, right? How is that condition coming? So let's look at these diagonals. See, let's say instead of writing those two diagonals, I wrote that these are the diagonals. Okay, so let's check what is the conditions that's getting followed over here. So you would find some similarity in the elements in all these diagonals. So what is the condition that is getting followed over here? So it is I equals to j, right? I is equals to j. What is the condition that is getting followed over here? Tell me. So 1, 0, 0, 1, what's the condition that is getting followed over here? Any condition, any similarity, anything that you can notice? I plus j equals to n minus 3. Or can we tell it as I plus j is equals to 1? Here I plus j is equals to 2. Here I plus j is equals to 3. Here I plus j is equals to 4. Here I plus j is equals to 5. Here I plus j is equals to 6. Yes. Or instead writing I equals to j, can I say this, that I plus j is equals to 0? Yes. So I plus j equals to 0, I plus j equals to 1, equals to 2, equals to 3, equals to 4, equals to 5, equals to 6. Yes. No. Achha. One quick question. How many diagonals will a matrix have? So let's say this is a 4 cross 4 matrix. How many diagonals is this matrix going to have? Achha, tell me how many diagonals this matrix has from this in this like left to right fashion. So how many such diagonals it has? So this is 4 cross 4, so it is 7, right? So for a 4 cross 4 matrix, it is 7. For a 5 cross 5, for a 10 cross 10. So the general formula is, okay, let's say we don't know the formula. Okay, so how can you guess? How can you actually know it? See, so this is one diagonal. This is two diagonal. Just look. So for each row, you are starting one diagonal. So for a row is equals to 0, you're starting one diagonal. Row equals to 1. Row equals to 2, you are starting one another diagonal. Row equals to 3, you are starting another diagonal. So number of rows that you have, that many diagonals you have. So how many rows you have? So you have n rows, right? So n diagonals that start from here. Does it end? No. Your number of columns, the number of columns that you are going to have, that many diagonals as well. So see the number of columns you have. So you have, let's say, m columns. So you already took one over here. So you take 1 column, 2 column, 3 column. So your columns coincidentally see here are also m. Okay, so it is m columns, but m minus 1, right? Because 1 you took as the row. So number of rows you had 1, 2, 3, 4. If you had a 5th row, so you would have like this as diagonal, which is like n row, right? Let's say it has 4 0, 4 1, 4 2, 4 3. So how your diagonals would look like? So this would be 1, this would be connected to this would be connected to this, and this would be the last diagonal. So how it is going to look like? So 0, 1, 2, 3, 4, the number of rows, which is n. And then finally m minus 1, these diagonals below this diagonal. So 1, 2, 3, m minus 1, these diagonals. How many columns you had? 4. So 4 minus 1. So this is 5 rows plus 4 minus 1. So 5 plus 3, 8 diagonals. Do you have 8 diagonals over here? If the matrix size is 5 cross 4, do you have 8 diagonals? Check. 1, 2, 3, 4, 5, 6, 7, 8. Yes, follows. Second thing, so the formula for the total number of diagonals in any matrix is from left to right is n plus m minus 1. Same goes for if you have to find these diagonals. Okay. These diagonals. So these similar to this, there are like these diagonals which are also n plus m minus 1. Acha, understood? How did we get n plus m minus 1? No doubts? Got it? Okay. So the number of rows you have, that many diagonals we are starting, and then like the number of columns you had, one less than that, right? Because for the last this diagonal, which is starting from one column itself, right? Chalo, no, did not understand. Chalo, listen to me once again. So let's say this is like the rows and columns that you have. Okay. So this is a 5 cross 4 matrix. Okay. So this is a 5 cross 4 matrix. Just look at here. So this is a 5 cross 4 matrix. Okay. Now 5 cross 4 matrix. Now look at this. So this is the first diagonal. This is the second diagonal. This is the third diagonal. See, for every row we are starting one diagonal, right? This is the fourth diagonal. And this is the fifth diagonal. For fifth row as well, we are starting one diagonal. So 5 diagonals over here. So the number of rows you have, so if you have n rows, that many diagonals. Okay. Now the number of columns you have, so that many diagonals will start from here. So this is the first diagonal, this is the second diagonal, this is third diagonal. Number of columns, but one less than that because you already have counted this diagonal. So this is m minus 1 diagonal. So this is plus m minus 1. What this? How did we get? Yes. Okay. So this is the total number of diagonals. Okay, row plus column minus 1. Yes.
So actually here there are only 7 diagonals, right?
If there are 7,
Or here only 7 diagonals.
yes,
are
only 7
possible.
diagonals. Yeah, in this order there are 7. Yes.
Yes,
No, 7, not 8, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 are there, right? Nah,
8.
8 are there. No? We will count 1, 2, 3, 4, 5, 6, 7, 8. Okay. So
Okay.
this last row I've written in red. Maybe that is confusing. Let me write this value in blue. I guess the change of color is confusing. So this is also a value 4, 0, 4, 1, 4, 2, 4, 3, right? Let's check the red lines 1, 2, 3, 4, 5, 6, 7, 8.
Yeah, now got it, sir. Actually, that's confusing.
Yeah, I got this. Okay, now understood. So there are 8 diagonals. So in general, for any matrix, the total number of left to right diagonals are going to be n plus m minus 1. Okay. And similarly, from right to left is also n plus m minus 1. Same way, right? The number of rows you have, that many diagonals you are going to start. So that is the number of rows, m, then the number of columns. Okay. Okay, still confused on the I plus j thing. Okay. So first you tell me understood the count of diagonals. That's clear. I'll explain this one again. I'll explain this thing again. Clear the count of diagonals. That's fine, right?
Sir,
Yes.
excuse me. For the reverse diagonal, it's giving uneven sums. I think. Like
so this is uneven matrix. Right? This is a 5 cross 4. So this is uneven, right? So in
when we are doing like in such a case, it's giving a pattern. It's returning a pattern like it's 0, 0, and 1 0 and 0 1 is just returning 1 as suppose. And where when we are just reversing it, it's giving uneven sums like 0 3 3 hai. So 0 2
Okay,
1
got it,
3.
got it. So you're telling there is no such pattern that is followed. Okay, I'll
Yeah.
explain that as well. I'll explain that part. So there is always a pattern. The pattern is like little bit tricky, just that, but there is a pattern. Okay. See, so we got this, but is there any similarity in the diagonals that we can use to print these diagonals? So let's say we are asked to print these all diagonals. So what is the similarity? So just look at here. So here, when we add I plus j, it's going to give us 0. On adding this, it gives us 1. On adding this, it gives us 2. On adding this, it gives us 3, right? So just check. Add these two index I and j, right? So you're going to get 3 for all the values in this diagonal. Okay. When you add this, you're going to get the same value for all the values in this diagonal, right? So basically, when you're adding the index, you are going to get this value that is starting from 0 to varying till the last diagonal. So what is the total number of diagonals over here? So it is 8, right? 10 plus m minus 1. So yeah, 8 diagonals. So it is varying from 0 to 9 plus minus 1. Yes, okay. So 8 diagonals. Or last one I missed, right? So I plus j is equals to 7. Right? Yeah. So, okay. So now it is varying from 0 to 7. Right? So you have 8 diagonals. So the sums is varying from 0 to 7. So let's first print this one. Then I'll explain you the other right one. We can figure out what's that. So, this is not the optimal solution. There is an optimal way to print it. I'm just writing one solution first, which you can understand. Okay. There is an optimal way. Today you try to figure out. If not, then I'll explain you the optimal way to print it. Okay, so how many diagonals do we need to print? So we need to print n plus m minus 1 diagonal. So our loop is going to run from 1 to okay, let's run it from 0 to less than n plus m minus 1. These many diagonals we have, I plus plus. Okay, let's add one more row so that this is like a non-square, so it looks a little bit 3 plus 4. Okay, so this is like the left diagonal. Okay. Let's do this 0. Okay. Now this question. Okay, so we have 0 to n plus, so our value is varying from 0 to 7. Okay, now how will we get diagonals? We just need to iterate through this. So okay, let's create this loop as k. Okay, outer loop, and we just need to go through the entire matrix to find out which all will have this particular sum. The first diagonal is going to have the sum as 0, so I less than equals to 0, I less than m, I plus plus. Then the j loop, which is going to run for the columns, for j equals to 0, j is less than m, j plus plus. Okay, you can do system dot out dot print. You can print a of I j, but we need to do it for all the values. No, we don't need to do it for all the values. We need to print it only if the diagonal condition is satisfied. So that's the first diagonal. The first diagonal is I plus j is double equals to k. I plus j is equals to k, so that is the first diagonal. 0, when k is 0, I plus j equals to 1. That's the second diagonal. I plus j equals to 2. That's the third diagonal. I plus j equals to 3. That's the fourth diagonal. Right? So once this condition is satisfied, we are going to print that diagonal. After we are done printing the diagonal, we would print it. After we are done printing the diagonal, we can print a new line. Okay. Now see. So for this is our matrix. Four rows, 3 columns. Right. At the first diagonal is this. Take a let's here. Let me expand this a little bit. Okay. Look at it. So this is the first diagonal we are seeing over here. There's a second diagonal 1, 2. We are seeing. Why do we see 2, 1? Achha, we will get this value first and then this value. Yes. So we are seeing it in this order. We are seeing in this order because we are getting this value first and this value second. We are seeing it in the reverse order. Okay. Okay, we can fix this by doing this column order traversal. I'll come to that. I'll just come to that. So when this is like the diagonal, which is from here to here, 3, 2, 3. So we are seeing this value. Then we are seeing 4, 5, 2, which is this diagonal. And then we are seeing 3, 4, which is this diagonal, and then 8, which is this diagonal. Okay. Now, how can we fix this? So this is like printing it in from this top to bottom, which is fine. But how can we print it from bottom to top? Any idea? Yes, I already see a suggestion in chat. Okay. So it is firstly accessing those values. So it is printing those. So we are traversing row wise. So you are getting the first row value first. So if you want to print it from bottom to top, you just need to run this loop in the reverse. So you just need to run this from M and this loop to N, and just change this to from this to J and this to I. Okay, done. Now if you run this, you should be seeing the correct order. So now see, you are seeing the correct order, right? So firstly, we are just changing the rows into columns. So we are doing a column order traversal and printing this. Okay. Got it? Understood? So you can print it from top to bottom, bottom to top. So this is like all the diagonals that's there from left to right. Similarly, you can figure out from these diagonals. I'll just give you the formula. I'll just give you the relation. Rest you have to figure out, right? If I tell you everything, what you all will do, right? Not do anything. Generally, I never tell this much things about like any concept. I let you students figure out diagonal, what is diagonal, how will you print this, because these are not concepts. These are logic that you need to learn to build, right? You will struggle initially. You will not be able to get this, how to do this. You will try to think. You'll waste a day, not waste a day. I'll say that is not wasting. That is learning, right? If you are learning something, trying to spend time, that's fine. This is a pattern kind of logic, and then you'll figure out, right? So I'll give you an idea. So I'll not tell you this because I told you enough about diagonals, so you should be able to guess this now. I haven't wrote the code of it. So let's check whether you are able to guess it or not. So this is 0, 3, this is 1, 3. So these are the diagonals, right? So right diagonals are this. Okay. Now tell me what is the relation between any one of this. That's it. That's the only question that I'm going to. So tell me what's the relation between this diagonal. So this is fine, right? I equals to J. This is not tricky. What's the relation between over here? Think. Relation hai. Okay. One thing I can guarantee, there is a relation. And that relation is constant among all the diagonals. No idea. See, so I'll give you one hint. Just observe these two values. So what's the difference that you see? So forget about everything. Okay? Forget about everything. So forget about this. Okay? Forget about this. Okay. Just observe these two values. So let's say this is a value. What's the diagonal value of this going to be? So what's the diagonal value of any cell in the matrix going to be? So any cell in the matrix, the diagonal values. So this is just the next row. So I increases by 1. This is just the next column. So J also increases by 1. Right? So this cell value is I plus 1, J plus 1. If this value is Ij. Yes. If this value is Ij, this cell's value is I plus 1, J plus 1. Right? Now, if this is I plus 1, J plus 1, what is this value? So this is I plus 2, J plus 2. Yes. Okay. Now think this as diagonal. ठीक है, अब इसको diagonal के terms में सोचो. So you got this information. ठीक है, चलो this is I plus 1, j plus 1, I plus 2, j plus 2. Okay. Think it in this form. Let's say. So what's the initial sum over here? So initial sum is 3. Okay. Okay. What's the initial sum over here? Initial sum is 2. And then it is changing to 2 plus. So I is going to increase by 1. J is going to increase by 1. So sum is going to change to 2, then to 4. Yeah. Now check over here. So initial sum is 1. Then it is going to change to 3. Then it is going to change to 5. Now look at this diagonal. Initial sum is 0. Then it is changing to 2, then it is changing to 4, then it is changing to 6. Because I and j are increasing, I is also increasing by 1, j is also increasing by 1, so these values are going to differ by 2. Okay, look at this diagonal. So here also the initial sum is, you have initial sum which is 1, then it is changing to 3, then 5, then 7. Okay, here the initial sum is 2, it changes to 4, it changes to 6, done. Here the initial sum is 3, it changes to 5, and here initial sum is 4. Achha. Now if you just look at the initial sum, it is varying from 3, 2, 1, 0, then again 1, 2, 3, 4. Got the pattern? No patterns, no series. So initially it is decreasing for the first few diagonals, then it's increasing. The initial value, every cell in this, every place in this diagonal is going to change from this. Or, you can think it in this way. The initial sum is varying from 0 minus 3. So this is 0 minus 3, 0 minus 2, 0 minus 1. Okay, you can just find out the difference between them. So I minus j is 3, I minus j is 2. And that is fixed. Now if you just do this, if this trick is complicated, you can just follow this way. So here I minus j is going to be 3, here I minus j is going to be 2, here I minus j is going to be 1, here I minus, sorry, minus 3, minus 2, minus 1, it is going to be, I minus j is going to be 0, here I minus j is going to be 1, I minus j is going to be 2, I minus j is going to be 3, I minus j is going to be 4. It is varying from minus 3 to 4. Now got it? Minus 3 to 4, it is varying. If you start the value from minus 3, now initial value would be somehow related to n and m. Figure that out. How is minus 3 related to n and m? What is that? How will you get minus 3? That why you are getting minus 3 over here? We are not neglecting negative. Is this red color visible clearly? I think red should be clearly visible. Yeah, on this screen it is visible. So it is varying from minus 3 to 4, right? In the alternate way, I minus j is varying from minus 3, minus 2, minus 1, then 0, 1, 2, 3, 4. Take a 3 cross 3 matrix, similar relation, you will find out I minus j. 5 cross 4 matrix, 10 cross 3 matrix, something you will find out a similar relation. Now, just figure out how you are getting this initial value, right? That's it. Okay. Got it? Okay. I gave you some idea about it. Now think through it. Try to write that logic is same kind of like loop you'll see. Also, if you understood these two parts, okay, got some idea, got some idea at least. Thoda kuch chamka, thoda idea laga what diagonal is, how can you print all the diagonals, how can you access it. So if you are done, if you understood that, what's the complexity of this logic? So this logic's complexity is, this is like assume like n and m. So this is n plus m and this is n into m. So this this is n plus m into n into m, right? So this is n into m, this is n plus m, right? So if you open the bracket, that is n square m plus n m square, right? Or if let's say it is if m is equals to n, so it is 2n cube, or you can simply say it is n cube, big of n cube. This is n cube complexity almost, right? N cube greater than n cube, right? So it is n cube complexity. Now, can you improve it to n square? So it can be actually improved from n cube to n square. Now, if you understood this, try to think how can you improve it to n square. Okay. what is the idea that I gave you? The innermost loops are going to waste your time, right? Innermost loops are going to run for additional iterations. You just need to figure out what are the additional iterations for which it is running. So for example, just look at this first diagonal. So first diagonal is going to have only one value, right? So when you're like, let's say this is your matrix 1 2 3 2 3. The first diagonal has only one value. And for what this loop is running? This loop is running for this entire matrix, and you're just printing one value out of it, because that one value is only going to satisfy this condition. For the second diagonal, you only have two values, and you're running this loop for the entire matrix just to print these two values. Right? Same would go like if this is a 100 cross 100 matrix, so first diagonal will still have one value, second diagonal will still have two values, third diagonal will still have three values, and you're running this loop for this entire matrix, which should not be the case. Right? So there should be some optimal way to print this. Try to figure out. Okay, if still you would not get it, I'll discuss it. I'll explain the solution, but try to think of this. Okay, how can you decrease from n cube to n square, and same goes for the other loop. So if you remove the k loop, so outermost loop you cannot remove, right? If you remove the k loop, it's just going to print the one diagonal, right? It's just going to print one diagonal, but we have to print all the diagonals, and you can actually print all the diagonals in n square logic. Okay, so if you just remove the k loop, that is going to print one diagonal like we were doing over here, right? So see, we have already done that. Simply remove j loop. That's also not going to solve the problem. So you have to think something different, right? Every time that logic is not going to work like we did on cadence. So thoda sa sochna padega, right? So this is like if you remove the k loop, it's going to be something like this. Where did I write that? Diagonal of a matrix. This one. We are printing one diagonal. Okay, so there is some relation that you need to figure out for each diagonal. Try to think of writing a loop in some different way. Right now, that's the problem for you all to solve. Think, right? I gave you ideas for what you can think, where you need to think. Okay. So this is it, all about two-dimensional matrix. Now you have questions like find out the maximum, minimum. There is one very interesting maximum minimum question. There is one right in the maze question. Right? We'll discuss these questions. Okay? We'll discuss this question. Try to solve these basic ones first. Print the diagonals. There is a spiral order matrix traversal. Now try to do that question. That is just like printing the rows and columns of the matrix by decreasing the size. Okay, boundary traversal of the matrix. So those questions. So today try to print this printing question so that you get a good grasp of what this two-dimensional matrix is. Once you are familiar, like used to printing this matrix in different way, then later when you get manipulation questions, your manipulation questions will be easier. Okay, so that's why the printing questions are there in the first assignment, and then the manipulation questions are there in the second assignment. Okay, so now try to figure this out. Try to solve these questions. I already gave you solutions to a lot of questions like diagonals, printing the diagonals. So there is like column order matrix, the transpose of the matrix. So all the questions, a lot of question solutions you already got. Okay. So and the remaining ones figure out. See, those are there in assignments. So all the questions are in the assignments itself. So the questions that I'm mentioning, they are there in assignments. Okay. Okay. Now let's cover the leftover part, which is like array addition and subtraction. I guess we all are asking it since a long time. So let's complete that. Okay. How much you completed the addition ones? Also, I shared the links right now in the chat as well. Notes. Yeah. So I've shared the link right in the chat. Let's do array addition. Array addition is done. Okay, chalo. Great. So I'll explain subtraction as well. Okay, now I'll see the difference, addition, subtraction. 15 minutes, both the questions I need. Subtraction, okay, we'll try to do it in 15 minutes. Okay, okay. So what is array addition? So let's say we are given two arrays. We just have to add them. Okay, so let's say this is our A array, which is having some value like 1, 2, 3, 1, 2, 4. Okay, and then we have a B array, and for like understanding, let's take it as different sizes. Let's take as 2, 9. Again, we also have some carry as well. Okay, so you have two arrays. They can be of equal, unequal size, and we have to figure out the legend diamond question. Take a diamond pattern भी बचा है. हाँ, वो भी तो बचा हुआ है. ठीक है, चलो diamond pattern कल सुबह करते हैं. ये मैं कंप्लीट करा देता हूं. एरेज के साथ ही है. सो वी आर ऑन द एरे मोड. सो लेट्स कंप्लीट दैट. डायमंड बटन कल सुबह प्रिंट कर लेंगे, ठीक है। चलो, I guess हाँ, tomorrow morning we again have a class. We'll meet just in a few hours. In less than 12 hours we have another class. Okay. Just notes will be available in the module or not. In the there also so for like the concept, there is already notes in the platform, right? That's there, right? There are a lot of notes that's present in the note section, right? So you can just navigate to the note section. There is a note section completely in the portal that you can use. Yes. So there is already notes that's given for the basic ones. I guess there is missing, which I have already informed them to add, right? But all the concept wise, I have like covered everything here, and I've mentioned few notes in between. But if you go to the notes, you already have the notes for all this advanced concept. From arrays, like you have everything. Arrays like arrays, string, linked list. So all the notes that's like important, that's there. Algorithms, right? So that's notes are there. There is one notes that I have added over here. So there is some change here. There is some update where the notes get added. So let me just check that. So actually, if you go to any lecture, there would be some notes that you should be able to see over here now. So yeah, so see, so there is some lecture notes that's there. So this is like my notes that I've added over here, right? So so the link that I shared for that particular class are now mapped to here. So you can easily see what we learned, right? So I've written all the things that we discussed in the class, right? So that is written over here. Now, if you want any detail of this, I generally suggest you can just type it in Google, this ASCII, all I think you'll get it. If you want to ask that recording, you have that recording right handy. So you can watch that recording as well. But for this, generally, you don't get theoretical questions. So that's why we have not burdened you with theory over here, right? So here you have like the suggested reading. Now, I know this time it was like the feature still came out late. So you might see notes, the notes having a little bit greater, but that's order is correct, right? So order would be correct. So your order would be from starting to bottom. Now, going forward, since this is already present, so you would see the notes mapped to the correct classes. So for example, let's say today I complete a class, whatever we have studied would be studied in this class. This would be there in today's notes. Okay, the notes that attached to today's session. How to organize notes. So you have that you have followed it. So like mostly like the code parts, you can break it down for your code understanding. You can organize them, right? I guess code part, you don't need to write notes. For codes, I don't suggest to maintain any notes because you need to understand it and you need to write it yourself, right? If I ever give you, there is no way you can mug up any code. There is no notes that's going to help you for code. For theory parts, you can create small notes, and whatever theory I have explained related to memory, related to those concepts, so you can keep small snippets with you. If you want, you prefer one note, if you prefer whiteboard, you prefer your physical notes or diary that you are maintaining, or any notes copy that you are maintaining. You can do whatever way you feel comfortable, right? I generally suggest you do it in your own pace. I never had that habit of maintaining it. So because I used to always lose them somewhere, even if I write it digitally or keep it physically, both used to get lost. So I preferred to understand this in so depth that it all remains with me, right? And I understand, I have that understanding. So try to remember it, try to recall this, try to write it somewhere so that if you forget it, you can remember this. But I guess generally बहुत छोटा सा concept, right? A small concept. If you use it every day, so code wise you don't need any notes. So for example, these codes, right? Today I've discussed just the codes. So this you don't need to know anything. There is no notes as such that I'd say that you need to write these things into any notes. A few things that you need to remember. For example, these things, right? This is one such thing that you can remember. So the default value for address is null. So this is one snippet that you can take from here. You can write it into your notes, right? So this would be a good habit to write notes. So what you can remember about array, nested array, 2D array, it is like a nested array inside another array, right? What is a jagged array? So this is one thing that you can write in your note. So all these snippets that I've written in between, while going through it, you can just write these small things into your code, into your logic. Here I've explained the concept about this. So this one you can write in your own notes, right? If you are preferring to write notes while continuing in the class, that you can do. or if you feel like the while like let's understand it the class, and after the class I will like watch the recording again and write the like snippets from it. I can watch it at 2x and write few snippets from it. That is also fine. Right? So note is like a personal thing. I always say how it's best suits you, right? How it's best suits you to remember it, right? I know it's always time. Always try to, yes, the best thing I would suggest is always try to make the shortest notes you can. So your notes should never exceed more than half a page for every class, right? Why I say note should not exceed for more than half a page. Let's say, for example, whenever let's say you would have generally 25 classes a month, right? 25 classes a month. Now, if you write 3-4 pages notes for each class, you're finally going to write 400-500 pages of notes, right? Which is not going to be any viable solution to go through before any interview. Notes should be something which you can go through before any interview, right? Yes. So it should be the minimum as possible, which should give you like the maximum amount of information you require, right? So that would be a quick revision of every concept that we learned. Yeah, if anyone has like, I'd say you can do this discussion in your WhatsApp groups. Okay, you have a WhatsApp group, you all are connected. Try everyone who have created notes till now, right? In whatever format, you all share all your notes, okay, in the WhatsApp. And today you all vote that which one, which note you all found was the best. Okay, you among yourself will find someone who has created all these notes in a very good way. Okay, so I was the person who used to borrow other people's notes and read it. So you can be that person. There is no problem in that, right? There are people who maintain it really well. I'm very bad at it, being honest. So I can give you the only suggestion I can give you is the least amount of things you have in your notes, the better it is. Okay? The more information and least amount of pages. More pages is more problem for you because it can't be a quick revision for revision notes, right? Some interview question are mostly asked. So all the questions that you have in assignments, these are like the interview questions that are mostly asked, right? So most asked questions in interviews are already there in assignments. Okay, so that you'll get in assignments. And the gym questions, gym section has tailored questions, right? So all the questions that you see are like interviews are asked in some interview, right? So okay. So let's start with this question. Let's complete these two questions quickly. So array addition, right? So what is array addition? So we are given two arrays. We are asked to add them. So the simplest solution that would come to your mind is create them as numbers, add them. Okay. Now there is one problem. What is the problem? If this array size is 100 or 1000, right? Or even 50, there is no data type. There is no integer, neither long, right? There is no data type that can store this large array. Right, even if you use big int, there is some data type like big integer which stores larger integers, but that would also fail for a 1000 size array or a 500 size array. So there is no way you can store this large number into a particular variable. So you cannot do this, right? That cannot be stored. So now you have to figure out some way using which you can add these arrays. Okay, so let's figure out. So let's say we are adding this arrays. So how we are going to add this array? So the array addition would look something like this. So we are going to add the last integer with the last integer. So, okay. So what is big integer? So let's say integer long we know. So integer is 4 bytes. Long is 8 bytes. So big integer is like a large integer. Okay. It's a custom data type which we can create up to 32 bytes, 64 bytes integer size we can create. Okay. So this is a very large integer, right? So integer long are already so large numbers. Big integer assume it a 32 byte size variable which can store such large numbers. It would be a very large number, right? But that would also fail, right? So this question is not to like convert this array into something like integer long or even big integer. That is not asked. Okay, you learn about big int like later when you do like something. For now, you don't need that. Okay. So what you need to do is you need to, let's say, add this array index wise. So what is the index that you need to add? So firstly, you need to add the last index. So last index 9 plus 4, 3. Okay. Get 1, 2 plus 2 plus 1. So 4 plus 1. Oh, sorry, 4 plus 1, we get 5. So we need to add these values index wise, and then we need to pass the carry as well. So here we added these two values, pass the carry. We added these two values, pass the carry. There was no carry, so we did not pass anything. The carry was 0. Now there was no value over here, so we kept on adding it. We got the final result. Now let's check how we can do it. Acha, first you tell me. So we are adding two arrays, so the result is also going to be array, right? So what is the size of this array going to be? So if you add two like different length numbers, if this is n, this is m, what is the size of the resultant array? It is maximum between both of them plus 1, right? This is the maximum length of this array going to be. Result array size is equals to maximum between n and m plus 1. Yes. Now, let's create an array of this size. Let's call it as result is equals to new int, and it is of size r. Okay. Now, okay, we found out a, b, we found out the result. Now, what we need to do is we need to find out the sum. Okay. So let's take three variables: I, which is going to start from n minus 1, j, which is going to start from m minus 1, k, which is going to start from r minus 1. So what we are going to do, see. Okay. What we are going to do here, can we take the size as max and then print the extra carry separately as last? Yes, you can do that as well. That is also fine. So if you, that is also a good suggestion. You can take this of maximum size, and if you have an extra carry, that you can print at the last. That is also fine. Okay. Okay, so let's do it in that approach. That way it will be easier. If you have to return the array, then that's a problem. Okay, that's a valid question. In the question that is given in the portal, you have to return the array. Okay, so let's take it in this way. Okay, so anyways, we'll handle it at the end, right? We don't need that value for now. So, okay, let's not worry about that. Okay. Okay, so now we have this value. Okay, we got this three. Now, why did I start from the end? See, so I and j are starting from the end because these are the two index which we need to add. So I and j. Why k is starting from end? This is the place where we need to store this value. So we will add I and j and we'll store it at k. Okay, now let's check. So till when we need to find out the sum. So until I is greater than equals to 0 and j is also greater than equals to 0. So until both the arrays have value, we'll find out this sum. If one of them exhausts, for example, j completes, j exhausts, there is no more values in j array, right? Second array, then we'll figure out what we need to do. Let's assume firstly that both of them has values, right? So we'll run this loop. Okay. Now what is the initial carry that we have? So initial carry is 0. That means we don't have any carry initially. Initially we are starting with carry 0. What's the first sum that we'll get? What is the first sum? So the first sum is nothing but a of I plus b of j plus the carry that we have, right? So right now we don't have any carry. Okay, so we did 4 plus 9, which is 13. So we got the sum is 13. Now, do we need to store 13 into the result? No. So what is the value that we need to store in the result? So result is 13 divided, okay. So result is 13 percentage 10. So if you got the value 13, so 13 percentage 10, that is equals to 3. This is your result. And what's the carry? 13 divided by 10. So this will get us 1. This is the carry. Yes. Okay. So what's the result value that you need to store? So result of k is going to be some percentage 10 and the carry is going to be sum divided by 10. Understood? How did we get this? Result is some percentage 10 and a carry is sum divided by 10. Easy. Achha. Now we stored the result. We took the carry as well. Okay. Now what we need to do? Next iteration, what we need to add? We need to add I will be decreased by 1, j will be decreased by 1, and k will also be decreased by 1. So let's decrease I by 1, j by 1, and k by 1. Done. So in the next iteration, I will be decreased by 1, j will be also decreased by 1, and k will also be decreased by 1. So I and j and k, all of them are decreased by 1. Next iteration, what will happen? So we have carry is equals to 1. We are going to get these two values. I is going to get 2, j is like 2, carry is 1. So we are going to add 2 plus 1. So this is going to come out to 5. So we'll get the sum as 5. Now what we'll do, once we get the sum as 5, we'll find out 5 percentage 10. So we'll get 5. we'll store 5 into the result array. So result of k is going to be 5. Earlier we stored 3, we stored now 5. Okay. Sum divided by 10. If you divide 5 by 10, what is the quotient you are going to get? You are going to get 0. So you are changing the carry from 1 to 0. So here when you added these two, you got the carry as 1. Now when you added this, you finally got the carry as 0. So now the carry is going to become 0. Now this is done. So I then again will decrease I, j and k. So I will come over here. J will decrease. Now see, j will decrease to -1. So I is still a valid index, which is 0, right? J has decreased to a value like -1 because there is no more values in j, right? So I is decreased to a valid index. I still has values, but j decreased to an index which is -1. K will always have values because k is greater than I plus j, right? K is greater than like maximum both of them plus 1, right? Okay. So now what's the left value? Whatever array is left. So let's say here what array is left? I array, right? J has exhausted. So if I array is still greater than 0, what we need to do is we just need to keep, we will just do the same thing, a of I plus, and there might be some carry that is also coming. So for example, if this was, let's say 9, okay, so we would have also got a carry as well, right? So if this was not 2, this was 9. So 9 plus 2 plus 1, so this would be 3, and we would have also got a carry. Instead of getting carry 0, we would have got a carry as 1, right? So we need to add this a of I plus carry, okay, and we need to just find out, again do the same thing, result of k is equals to some percentage 10, and if there is still carry, so we need to do the carry as sum divided by 10. We need to decrease I and we need to decrease k. Understood what I did over here? What this loop is doing? So if the j array exhausts over here and I array still has value, so what I did, I checked until I becomes 0, I'll keep on finding out the sum. I'll store the result in the result array. I'll find out the carries, right? So let's say this was even a like larger value, right? So let's say this is not looks like this. It is even a lengthier number. The first number is even longer. So let's say this number looks something like this. So let's say this is the second array. You need to add them, and this is like 4, 3, 8. This is the first array, and this is the second array, and you need to add 99 to it. So first iteration, I is here, j is here. So you'll do this array. Okay, I'll explain the array subtraction. I guess we need some more time. We might exhaust on time. Okay, let's complete this one first. 3. We'll get 1 carry. So 9 plus 2, 11, 1, 12, 2. We got 1 carry. Okay, let's say this is 9. Okay, so we'll see how this would be. So here j array has exhausted. This condition would be false, right? After this iteration, when j would be here, so j is exhausted, and we don't have any values for j. But I still has values. Carry still valid. So what we are checking is I greater than 0. Yes. Then we are adding a of I plus carry. So 9 plus 1, 10. So we get the value of 0 over here. So we put that percentage 10 over here. We still get a carry as 1. So carry is still 1. We still pass on that carry. Okay. We decrease I, we decrease k. We don't decrease j, j is done. Right. So we decrease I next iteration, I will point to this 3. Instead of 9, I is going to point to 3. So 3 plus 1, we'll get the sum as 4. So we'll store 4 into here. Now the carry becomes 0. So next iteration carry is 0. The sum divided by 10, 4 divided by 10 is 0. I minus minus, so I changes its value to here. K changes its value to here. So 4 plus 0, which is 4. I changes its value to here. 8 plus 0, which is 8. I changes its value to here. Now I array exhaust, and finally we get this as the result, which is the correct result. Right? Okay. Now the second second question is what if we have just the reverse of it, right? With this larger number is the second number. Yes, if I is small and the j is larger, so what you need to do, just copy this loop, run this loop for j. Now tell me one thing, okay, out of these two loops only one loop is going to run. Can you tell me why? Out of these two loops only one loop is going to run. Why? So okay,
क्योंकि I और J में से कोई एक ही छोटा ही होगा.
Right. So if both of them are greater than 0, right? If both of them are greater than equals to 0, then this loop will never end, right? If both of them are greater than equals to 0, the first loop will never end, and we will will be still in the first loop. This loop will only end if one of them has become less than 0, right? So if let's say j has become less than 0, which is this case, so this loop would run. This loop would never run because j is already -1, right? If j has become I has become -1, so I has become first number is smaller, so I would become -1, so this would not run, and this loop will only run. Okay, got it? Now there is ways to handle this thing in the same loop by you can write this as OR, and you can put this as if checks inside here to find out the sum, which is like fine, right? So I say like you can do this, you can put OR over here, and you can check inside if else condition. If I is valid index, you can add I. If j is valid index, you can add j. So that is also fine. Okay. Or you can use this as well. This for like, I think this is like little bit cleaner inside loop. You don't have if else condition, but both of them have the same complexity, same logic. Okay, understood? I know there is a little bit of code duplication over here. Okay, so that's fine, but okay. Code optimization. So this is optimized, right? See, so this is like how. So how is this not optimized? You have a few redundant operations like this. Yes, I agree. So these operations are few redundant. We are writing it again and again, but you can do that inside if checks. That's fine. That might look cleaner, right? Okay. Complexity wise, it's same, right? So if you do it inside if else, if you do it over here, you're still finding out same number of additions. You're doing the same number of iterations, right? So you're like only one of these loops are going to run, or both of them will never run. So you're never running that any number of some. So time wise, both the logics are going to take the same amount of time. Okay, clear? So let me tell you the alternative. Instead of telling this, let me just copy paste and so instead of writing these three loops, you can do it in this way. So you can write a OR over here, and inside this loop you can check if I is greater than equals to 0. If this condition is true, then you can add. Okay, you can start a sum which is having the carry. So sum would initially have the carry. You can add sum plus sum is equals to sum plus a of I. Else, if this is not true, then this is definitely going to be true. So sum is equals to sum plus d of j. Then move this statement. So you can do this in a single loop by writing this if else. Okay. So this is also fine, or you can break it into 3 loops. Okay, understood? Okay. Now at the end also you might have a still carry, right? You might still have a carry at the end. So for example, if you are adding let's say 9999 with a single line. Okay, so you'll get this is 18, 9 plus 1 10 0, 9 plus 1 10 0, 9 plus 1 10 0. You still have one carry, and both the arrays as exhausted. J also has exhausted, I also has exhausted, and you still have a carry at the start. Now whatever is the carry, you just need to put it at result of 0. So result of k would be equal to that same value. You just need to put the carry there. If it is 0, it won't change anything. If it is 1, you just need to put it at the start. Okay, now if you just print it, so for int I equals to 0, I less than n, I plus plus. System dot out dot println. Let's just to print a of k, a of I. Okay, not a of I, result of I. And it is not n, it is r. Okay. Okay. Last carry, how did I handle? So I just put it at the start of the result, right? So if this last carry is just remaining 1, let's we just handle it in the last carry. Okay, understood? So last carry is just 1. We just put it at the start of this index. Whatever is the k, that index we just put it, right? Okay. Now let's check. I is already declared, right? K. Just write it as L. Okay, I know there is one additional carry at the start. I will handle it. Don't worry. Let's run this. I guess we are getting 0, 1, 5, 3, which is fine. right? For this array, we are going to get so 1, 2, 4, 2 9s. We are going to get 0, 1, 5, 3. One leading 0 is there at the start. Okay. Now let's try to find out the variations, whether we are going to get the correct result. So let's check 9, 9, 9, and this is just a single 9. Okay. Let's run this. So now in this situation, your arrays okay, so see, now you're getting 1008. So that leading carry is also getting added to your solution. Okay, understood? Now you can prefer whichever one you feel comfortable, right? You feel writing it both of them in the all the 3 loops in a single loop by writing if else, that is also fine. If you feel writing breaking into 3 loops, that looks easier for you, that also you can do. Okay, that's just 2 ways of writing the logic. Time complexity wise, it is same. Okay, so time wise it is same. If this looks cleaner, like it is like initially it is difficult to explain this if else checks to students. That's why I've explained it using this. Okay, but if you feel comfortable, you are able to understand this if else checks, so you can write it fine. Otherwise, this is anyways any day is going to work. Say string also, you are going to have the same problem, right? String also, string addition doesn't work. There is no addition operation in string, it joins them, it just concatenates it. So anyways need to traverse the string and add it character by character. That is also going to be the same problem. Now string in string concatenation is a big problem because concatenation operation is order n, that is not order 1. Okay, so a string concatenation is order n, that is not order 1. Okay, now the last problem over here is ki what if this result has a leading 0? This result make leading 0, right? So let me just copy this because this is our solution, right? So this is our solution. Okay, let me open it in the portal. So where is this question? This is in array 1. So array addition. Okay, I'll explain how this returning works. Okay, so let's see. So in this question, see what you're given some sim a b arrays and an m size, and you are asked to do this. So let's say we copy paste this and we just copy this part of the object, right? So this is already there and m, so we just have to copy this one. Okay, let's just paste this. Okay, so that is optimized. That's the correct way that I would also do. Okay. Okay, I did not copy the end. Why did it not print it? I just printed the first loop. Nice. I copied the entire thing and it just printed this part. Okay. And at the end you can return a result. Now there is one problem I know that we'll fix now. Okay, so let's say we give these 2 arrays as input, so it's going to tell me the sum correct because there is with one leading 0, right? So what's the leading 0? 0, 4, 4. That's the leading 0 that we are seeing, one leading 0 at the start. Now if I try to add these 2 values, here also we'll see one leading 0. So why there is a leading 0? Because see, we have created this of length plus 1, right? We have 1 extra length. So these 2 arrays, what's the maximum between both of them, right? So the maximum between both of them is 4, and our array that we created is 4 plus 1 side, which is 5, right? So we created an array of 5 lengths. So there is like 4 values we have already put the value, and the 5th value, there is no leading carry, so that's why we have put a 0 over there, right? So there is no leading carry, so that value is 0, right? We need to remove this. So what we need to do is, we need to check if result of 0 is equals to 0, or you can even check for carry, right? You can either check for result of 0 or you can check for carry, whatever is carry that you have anyway stored in result of 0, right? So you can check for any one of them, that's going to be fine. Now once you get that, okay, now once you get whatever is the result of 0 or the carry, now you just need to remove that. If it is 0, you just need to remove it. How can you remove it? Now remember I told you arrays are immutable, so you cannot delete a index from the array, because see, when you asked for the compiler for memory, it gave you the entire array, right? So when you're printing it, you can skip it. When you're printing it, you can skip it, But when you're returning it, you cannot skip that, or because you cannot delete something, right? So you need to create an array, new array altogether. Let's call it as result2. And what is the size of this going to be? So whatever size the previous array had, just subtract 1 from it. So this is the size of new array, right? And just store all the values in the current array into this new array. So let's call it as L is equals to 0, L is less than R, L plus plus. Okay, so let's call it as L to R minus 1, 0 to R minus 1. In result2, I want to store result2 of L, I want to store result of L plus 1. Done. And we can return result2. Now, if you can change the return type, but that is not the correct solution, because in let's say you get the same question in the exam where you are not allowed to change this driver code. So for example, here you are allowed to change the driver code, but at times you are not even allowed to change this. In lead code, you won't be able to see this driver code, right? So at times you are not allowed to change this, you are not able to see this. So you need to know how you can get the result without even changing this. So what we did, we just checked, is the first cell having a 0 value? If yes, then we are removing that. So how we are removing it? So we cannot change the current array. There is no way you can delete one index from the array. That is not possible. That is not feasible. That arrays are immutable. We cannot do that, right? So what we can do is we can create a new array of 1 less size. We can copy all the values that's there in the result array into this new array, and then we can return this new array. Now, if I run the same code, you are not going to see any leading zeros. Okay, understood? See, no leading zeros, and if you submit this, this should be perfect. Any push pop methods? So arrays does not have something like that. If you don't so later we'll understand about array list, which is like flexible arrays that we can create, right? So there we'll understand how we can get this, how can we create an array of a flexible size. So there you won't need to do this operation, but since this question is asking return in array, right? So you just need to do it in form of array, right? So the best thing is this, which you can do. Okay. Understood? If array lists are flexible, so there is problems with flexibility, right? That is problems that come with flexibility. So array list is flexible, but it cannot violate any memory laws that we have, right? So memory there is certain laws that we learned, right? So we can access certain things in overtime. If we want to create a something in array, we need to, what happened to this compile is not working. So we need to ask the memory in advance, right? What's the size of this? So there is certain constraints that will come, right? Agar itna simple hota, then we would have not studied arrays, right? Okay. Okay. So there is no test case needed if these constants are little bit higher, right? If these constants are like 20, 30, so your code would fail, right? If you have converted it into numbers, even long integers will not be able to store 30 size numbers. Okay. Understood this logic? Especially this last part where we are removing this getting zeros. Now clear? Array addition. So this last part, let me copy this over here. I'll put it over here. I'll check the code. Okay. So this is just for the coding one. So I've pasted the entire logic over here. Now you can go through this. Chalo, subtraction question you want to try today? Or yes, okay. So now try the subtraction question. Same logic, there is only one constant. Okay, I already told you, now that would make more sense. Yes. So this is like the approach is same. Okay. So there is like, instead of carry, you have to take care of that like borrow. Okay. So what are the things that's going to change? Instead of carry, you need to check for borrow. Now in subtraction, there is one problem. Okay, what's the problem is, you cannot subtract a lower number, like 23 cannot subtract 947. So this cannot be done, right? This cannot be done You need to figure out first the larger number and then you have to do subtraction. So for example, let's say if A is like, I'm talking about length, right? So if A is a greater value, if A is greater than B, then you need to do some subtraction. Then you need to do A minus B. Otherwise, you need to do B minus A. Okay. Now you have to figure this out. When you need to do A minus B, when you need to do B minus A. How will you check which array is greater? Okay. Which array is greater? How will you check that? You need to figure out. Okay. So firstly, like the basic check is you can check using length, right? But the length can be same and the numbers can still vary, right? Right. So let's say here you can check with A of 0, but A of 0 can be still same and the number can still be vary. And the number can still vary. So first element check will not work because the first element can still be same and the second element might vary. And the first, second, third element will be same and fourth element might vary. So you have to figure out the first non-matching element. So let me tell you this logic. Okay. So this is small hint that you can take. I know the class is already over time, but okay, I know it always goes straight to 12. So let's say you are given two arrays. Let me copy the same two arrays. Okay. Let's do this 4 lines. Okay, so let's say you have these two arrays, and let's say you just have to figure out which array is larger one. Okay, or both of them are equal. Say 7. You will not be able to convert arrays into single numbers, right? So you need to compare them in the form of arrays. So if you if you convert it into numbers, then the entire problem is solved, right? If you are allowed to convert it into numbers, in general, like even if it's running on the R portal, there is no test case that is checking it for now. But this is not the solution that I would say you should do. You should go with, right? We should try to understand this solution because this is the solution that you would be solving. You would be seeing. Okay. Okay. Now check this. How will we compare? So let's say both of them are of equal length, right? So then only you will compare. If the lengths are different, then you can automatically know, right? If the length is different, then you will know A is greater than B. So you can just check. If N is greater than M, then you can simply say A is greater than B, right? Else if N is less than M, then B is greater than A, right? Or at the end, final else. Now, if both the lengths are equal, then which one is greater, that we need to figure out. So how can you do that? We just need to run a loop for n. And you need to find out the first non-matching digit. So if A of I is not equals to B of I. So if they are equal, then you don't need to do anything. Right? If A of I is not equals to B of I, then you need to check. Okay. So, or you can check if A of I is greater than B of I. Flag is equal to, let's say, 0. If A of I is greater than B of I, you put the flag as 1. Else, if, and this if is condition is important, you cannot put as else. If A of I is less than B of I. Okay, then flag is 2. Now, can you tell me what does flag equals to 0 means? What does flag equals to 1 means? And what does flag equals to 2 means? Also needs to add a break over here. Hello. Tell me what does flag equals to 0, flag equals to 1, flag equals to 2 means. So after this loop, if flag is 0, what does it mean? If flag is equals to 1, what does it mean? I give you the logic. Now tell me what's you understand from this. Okay, see. So what I did, if both the array lengths are equal, so I ran one loop. I checked if A of I is greater than B of J, then I changed it to 1. If they are equal, then I don't change it. If they are equal, then this condition is not true. See, if A of I and B of J is equal, then this is also not true and this is also not true. So flag is not going to change if both of them are equal, right? So if both of them are equal at all the indices, from like all the indices, all the 3 index, they are equal, then none of these conditions satisfy, and at the end we still have flag equals to 0. That means both the numbers are equal. Okay. Now if its flag is equals to 1, what does it mean? That okay, this was equal, first number was greater, right? So we can get A is greater than B. And if flag equals to 2, so A is less than B. Understood? So how can you check if the array size are equal, which number is greater? Now, if you know which number is greater, you can immediately figure out, right, which one to which logic to run. Can we create an actual number by using array element? Yes, you can. You can create an actual number. The only thing I am telling here is in this particular question, you should not be doing it, or in any question where a number is represented by array, you should not try to convert it into number and then do operation. You should try to use the array to do the operation. Okay. Yes. Understood? Doubts? Sorry, someone was trying to speak something. I was getting some audio, but I cut you again and again. I don't know. Any doubts? Anything? No? Okay. So I gave you hints. I gave you the idea. Now that borrow logic, thoda sa figure out karo, thoda sa socho, right? I gave you carry wala logic. I told you how you can trim that array length, right? All the things I gave you. That same logic in case of difference, now the trimming is going to be a little bit different. See, in case of subtraction, okay, let's say you're subtracting this, and you're subtracting, let's say you're subtracting 992 and you're subtracting 941. Okay, so what's the result? Or let's say 991. So what's the result you're going to get? You're going to get 001. Now what you have to return in this situation? You just have to return an array having a single 1, right? Your size is going to differ, so you have to remove all the leading zeros. Now figure out a logic. How can you recreate a new array removing all the leading zeros from the array? Okay, so have an array which can have a lot of leading zeros. You have to create a new array which has no leading zeros. You have to remove all the leading zeros. फ्लैग का क्या यूज था? सो ब्रेक लिख सकते थे, बट ब्रेक हमें बताएगा नहीं ना कि ब्रेक कहाँ से हुआ लूप, राइट? व्हेन डिड द लूप एंड? डिड इट एंड बाय itself? Did it end by this break, or did it end by this break? Will not be able to know, right? So flag is telling me which break ended the loop, right? Or did the break not even end the loop? So if the flag is 0, that means none of the break ended the loop. It ended by itself, right? This condition was false, which means both the number are equal. If flag is 1, that means it ended by this if conditions break, so which means A is greater than B. And if flag is 2, that means it ended by this conditions break. Now you can figure out that logic. How will you remove those leading zeros? That you can think. So there is a lot of things to think in this question. Think it in terms of small problem. Firstly, finding out the larger number. How will you remove that trailing leading zeros, right? You have so many leading zeros. How will you remove? Removing a single leading zero was easy, right? Because you just checked if this has a leading zero, you just wrote a logic that would be removing it, right? But when you have a lot of leading zeros, then you have to think of some logic, right? So think of that. Okay. Again, subtraction one logic that you have to figure out, right? Subtraction logic is similar to this, right? A little bit different, but okay, you can, I guess that is something you can figure out. If you add all element, maximum sum is large. I did not get that question, moment. All elements. Any way to create an array of unknown size? No. So if you want to create an array, you need to tell the size, right? The same thing again sticks to there, right? In memory, you cannot ask a memory to the machine without telling the size. You cannot tell the machine that give me some memory, I'll tell you the size later. Memory is going to tell me, right? How will I give you any memory if you don't tell me the size, right? So same logic, compiler needs to tell to the operating system that this is the amount of memory I need. Then only operating system will give it. Array list also, it does the same thing. I'll tell you about array list. You'll be amazed to know how it handles memory, right? No one thinks like, everyone thinks it as a flexible array. It is not a flexible array. Okay, it is the normal array, just with the one additional advantage that it does. Okay. If we add all the elements and the larger sum is larger array for subtraction, no, does not mean necessarily, right? If you add all the elements, it will not result in the larger ones. For example, this can be one array, okay, and the other array is this. So now which is the larger number? This is the larger number, right? This is the smaller number, but the sum wise, this is larger and this is smaller, right? So using sum, you cannot predict which number is larger. Got it? Okay, I guess today's class was again very interesting. I don't know, we are having very interesting classes nowadays. The classes are interesting. You all are asking very good questions. We are going. Okay. So you have the subtraction question to solve. I gave you the addition logic. For those who did not do the addition question, you can try to see the logic. You can try to write it yourself, right? I've read somewhere to create dynamic array in Java. So dynamic array means like you're creating array on the fly, which is on the runtime, right? That is not it is like so in reality, dynamic array, what does it mean? You're creating an array during runtime, right? So every array is dynamic in that sense. But if you mean that by dynamic that we can create array without specifying size, that is not possible. That we cannot create not even arrays. There is no such data structure that exists which we can create without specifying the size to memory. Right? That is fundamentally not possible, right? Because fundamentally, if we want to create something, store something in memory, we want to tell the size, right? A beta variable, for that the size is fixed, any normal integer, float, boolean, double. If we create arrays, we just create it of a larger size. That's it. Array list is just an extension of arrays that we have. It doesn't violate that memory rule, or neither any other data structure does. Can we find the index till last 0 index and do a size in index last 0 index? Yes. So that's the correct logic. That's the correct logic. So you need to find out the last 0 index. You can do the size minus that last 0 index. You'll create the new array of that size and then copy the values from that index to the end. Yes. So the codes will also get added into the modules. So that's there, right? Now I showed you the feature that's already there in the portal. So that is going to be added. You can keep this note for today, right? I'm sharing right away in case you want to jump to like the codes right now. You can check it. Within few hours, the notes would also be there in the portal. Okay. So that I can't do, right? That access is not with me. So from next module, it would be there. Right now, my account doesn't have that feature. So that doesn't allow me to edit. But yeah, from next module, this would be there in my creds as well. There is some like technical challenge to add it to my cred. So okay. So from next modules, this problem should also solve the classes. The instructor itself would add the notes in the portal. Okay. So I've shared you the link. You can copy this for now, right? Nowadays classes are fun. Yes. So these concepts are interesting, right? So now the actual fun is begin, which is like the actual data sheet. From here on, everything is going to be interesting. And I am like waiting myself for the sorting and the array list classes. Those are going to be even more interesting and fun. Okay. Hello. Thank you, everyone. Solve all the assignment questions. Tomorrow we'll discuss. We have class at 11. So do join in morning. I will know you have less time, but if whatever time you get, please practice questions, solve them so that we can have more doubts tomorrow. Break on Sunday. So Sunday we don't, I'll generally not take classes. That's like a contest discussion. Right. So whatever contest you'll have tomorrow, we'll just discuss those questions. Okay. So 3 questions, we'll just discuss them. That's it. And yeah, if you have doubts from gym, that will take up on Sunday. If you have like anything to revise, that we can take up. Okay. Tomorrow we'll try to do questions, and I don't think there is a new concept. So there is like 2D arrays just that we'll try to revise. Time space complexity. We'll try to solve questions and what you might get in your exam that's there tomorrow. Okay. Thank you, everyone. Good night. Bye-bye. Take care. See you all tomorrow. Bye-bye.